Chapter 13, Letter 13, in which I particularly try to establish how lightning circulates through the clouds from places on the earth abundant in electric fire to places respectively lacking in it. Generally, such a circulation of all the temporal electric fire is confirmed. The correspondence of such atmospheric circulation with some similar subterranean circulation is demonstrated. The possibility of this subterranean circulation is vindicated against some common objections. Proposition 141. Clouds are not the producers of lightning, but merely the conductors, that is to say. Lightning is electric fire that strikes from the earth, where it is abundant, and travels through the clouds, discharging into the earth, where it is respectively deficient. 210. At first, it was believed that the essence of storms consisted merely of an accumulation of unevenly electric clouds. The cause of such uneven electricity was either not sought or was fabricated. It was thought that when unevenly electric clouds united, their electric fire would equalize, and there would no longer be any lightning or other electrical phenomena. But now the cohesive observation shows me that, in truth, the first lightning that strikes during a storm aims to increase the amplitude, density, unity, and uniformity of the storm clouds. But that lightning does not cease after such a union, which should occur if lightning were solely produced by the uneven electricity of the clouds, and if in this way the clouds were the producer. On the contrary, it is quite the opposite. That is to say, as the clouds have become more densely packed and united, the lightning strikes in greater numbers and more horrendously than ever. 211. But allow me, esteemed doctor, to prove even better this important and systematic truth by returning once again to the alterations that occur in storms corresponding to the lightning that strikes my conducting wires. That very capable Dr. Verratti, in the only experiment he could conduct regarding the electricity of clouds, once observed such an alteration in his rod, when those who were repairing it were suddenly and strongly shocked. And he noted very well the correspondence of the lightning that struck a tree some distance away. In my daily observations of that time, I have repeatedly and often experienced such alterations, and I have distinguished their correspondence with the lightning. 212. Thus, primarily the amplitude, strength, and number of the aforementioned alterations evidently support my intent. For a flash, however distant, in one extremity of the storm clouds induces a noticeable alteration in the conducting wires, and at the extremity of the branch, which clearly proves that such an alteration does not proceed from any artificial cloud that newly joins the total body of storm clouds, but originates from a vast source, which is the earth, and propagates it widely through the storm clouds to the other point, the earth where my observatory is located. The violent, thunderous, and fiery sparks that suddenly erupt when lightning flashes not far from my observatory. As noted by Mr. Dr. Verratti during a lightning event that also occurred several miles away, remarkably confirm that the sudden lightning fire does not originate from the clouds, which were indeed united, but that, precisely by striking, it must proceed from the fire within them. The large number of such alterations, which sometimes occur in hundreds during a single storm, certainly indicates that it is not in the clouds, which are united and dense, and consequently have no other difference in electricity to cause lightning, but that the source must be investigated in the fire. 213. To prove this truth, I will then examine in a very particular way the various modes of these alterations. For sometimes the alterations consist in the sudden accumulation of electricity, however. They are usually such that while a flash occurs between the earth and some distant part of the storm clouds, a considerable amount of fire is similarly discharged between the earth and the part of the clouds that I observe. Now, this fact, considered metaphysically, could occur in three different ways, namely either that the fire flows from the clouds to the earth everywhere, or that it flows from the earth to the clouds everywhere, or that in some places it flows from the clouds to the earth, and in other places from the earth to the clouds. But the first two cases contradict certain particular facts, for if the fire flows everywhere from the clouds to the earth, or from the earth to the clouds, it will only discharge the excessive fire, so much so that it will equalize the electricity of the clouds and the earth. And the electricity of the clouds will never be found to change in the opposite direction after the flash, which is something we often observe. Therefore, it must be said that the new fire, which at the moment of the flash flows between my observatory and the part of the clouds that I observe, is animated and moved by the new fire that flows in the opposite direction between the clouds and the earth at the location of the flash, and that consequently the clouds do not store the lightning within themselves, but only conduct it from one part of the earth that is abundant to a part that is relatively lacking, 214. And after proving in this way the circulation of lightning, it is very easy to see how all the individual mentioned alterations fully and effectively agree, from which agreement the truth is increasingly evident, as well as the various manners of this circulation. Proposition 12 to explain all the various manners of the alterations that occur in the conducting wires during a flash or lightning, 215. If the electricity changes in the opposite direction, it is a sign that the lightning is a new current of fire between the earth and the clouds, which either induces so much fire in the clouds, if they were electrically deficient, that it extinguishes the deficiency and induces an excess, or it takes away so much fire from the clouds, if they were electrically excessive, that it removes all the excessive fire and part of the natural, 216. If the electricity is lacking, it is a sign that through the lightning, so much fire enters from the earth into the clouds, if they were electrically deficient, that it effectively equalizes them. Or so much exits from the clouds towards the earth, if they were electrically excessive, as to exactly equal the excess itself, 217.3. If the electricity is weak, it is a sign that the lightning is carried by only one side of the excess of the clouds, if they were electrically excessive, or of the earth, if the clouds were electrically deficient, 218.5. If the electricity is born, it is a sign that the lightning either induces new fire from the earth into the clouds, which had only their natural quantity, or takes away from the clouds some part of that natural quantity into the earth. 219. With equal ease, the other alterations can be explained, which then occur differently from the first, corresponding to the first moment of the flash. 220. The first alteration is strong and consists of many truly lightning-like sparks, which occur very quickly and are very thunderous. And this shows the immense quantity of fire, which the lightning either induces from the earth into the clouds, or takes away from the clouds into the earth, which quantity must circulate separately and with some succession, since a large body never discharges effectively through a single spark. 221 is universally then. After the first alteration, various other alterations occur, namely, either the electricity is lacking or invigorated by the first alteration, or it returns to its original state, depending on whether it weakens or invigorates the new current from which the first alteration proceeded. 222. Not only those sudden and fleeting alterations, but also the permanent ones serve to prove the circulation of the lightning material, and find in this a very suitable explanation. 223. In the simplest storms, which do not involve a large area of land with their single cloud, the electricity in my observatory changes little. It greatly increases or decreases and does not change in the opposite direction, because the earth, for example, corresponding to the cloud, is abundantly charged, and that over which the branch spreads is relatively lacking in electric fire, or vice versa. Thus, abundantly from that, the electric fire rebounds in my observatory, or vice versa. 224, letter 13, 2. But in more complex storms, which form many clouds and spread over very various and extensive areas, the alterations are greater in number and value, especially as I observe when new flashes and new thunders arise from some new source, and very far from the site of the first flashes and the first thunders, the electricity changes in the opposite direction, because different and very distant parts of the earth have different values of electricity with respect to each other, so that the electricity of my observatory, which must result from the predominance that the various abundantly charged places will have with respect to relatively lacking places, or vice versa, will change in strength depending on the quality depending on whether there are new sources or new discharges of electric fire, or the alterations of the first sources or the first discharges, or many combinations of these causes, will reverse the same predominance. And although the observations of the circulating fire guide us to recognize in the earth these various sources and those various discharges of electric fire, I still believe that it will not be at all superfluous if I endeavor to further clarify such truths, proving how they wonderfully agree with certain portentous facts of some meteors, and they provide a very suitable explanation for them. Proposition 13. Certain rains seem to confirm the circulation of electric fire from one place on Earth to another through clouds. And in such circulation, they find a very suitable explanation. 226. Since every rain proceeds from clouds that form in certain parts of that globe and then dissolve over other parts, it is the electric fire that excites the clouds and dissolves them into rain, as we will see in more detail shortly. It seems that every rain cloud through its circulation proves the circulation of electric fire, 227. However, there are certain rains that, due to their particular characteristics, seem to advance this idea more specifically. Such are the rains of salt water, of ashes, and of all the various drizzling rains, which were once called mud rains. I will provide a few examples of these. In number 239 of the Transactions of the Royal Society, Mr. Derham reports a stormy rain of seawater that occurred in Lewes 20 miles from the sea, which left a false vapor on the grass and on the fruits. In the same place, Leeuwenhoek reports another similar rain of seawater, which in less than half an hour fogged and covered the windows with opaque white particles, which, when observed under the microscope, were very real crystals of common salt. 228. Indeed, these authors note that those rains were accompanied by violent winds, but Leeuwenhoek also notes that the windows facing east were fogged, and thus were affected by the wind blowing from the southwest, while those facing the opposite direction found little or nothing of that on their windows against which the rain had been carried. 229. Furthermore, in number 21 of the same Transactions, Captain Baddeley reports a rain of earth and ashes that occurred in the archipelago in the Gulf of Volo, where he was anchored, and in other places more than 100 leagues away, as was learned from a vessel that was proceeding to Volo from St. Giovanni. He states that this rain of earth and ashes began at 10 o'clock at night and ended at 2 in the morning, that it fell to a height of 3 inches, that he compared the ashes from his vessel with those from another vessel, which at that time was 100 leagues away, that this rain occurred during an eruption of Vesuvius, and that at the time it happened, there was no wind that could carry the ashes. Thus, one must seek another moving principle that could have brought them to such a distance and distributed them over such a space, and effectively scattered them like rain for such a long time. For such things can all be attributed solely to the force of the eruption. Now this principle is certainly the electric fire, which, circulating through common rains, distributes and scatters them, and which, as various authors have written about Vesuvius, and most recently the learned Father Della Torre, is seen to flash during eruptions of that mountain, forming sudden lightning bolts to which all the characteristics attributed are of electric fire. This fire, for example, bursting from the interior of the mountain, carries with it the different ashes and extensively distributes them over the farthest lands, and can distribute them like rain, in which, as particularly sparkling, it must diffuse them evenly. 230. The fine moist earth, while it is wet, then of a tan color, soil, impervious to calamity, etc., which, as I have said elsewhere, fell last year extensively over many and very distant places in Piedmont, probably had the same cause. It fell while there was no strong wind blowing, and was distributed everywhere with great uniformity. Some particular source of electric fire, for it thundered and flashed very strongly, must have lifted it from the ground, and thus distributed it according to the spaces of its circulation, and over the lands distributed it evenly. 231. But to more clearly demonstrate the variety of outlets and sources of electric fire in different parts of the earth, the following proposition will serve more immediately. Proposition the 14th. Lightning strikes from deep within the earth at a certain depth, and at a certain depth it is buried. 2. There is no room for doubt since some strike from clouds to the earth, while others strike from the earth to clouds. And all those that directly enter or strike will create very deep holes. The fields are full of such examples. The lightning described by Mr. Barham in number 357 of the Transactions of the Royal Society created a hole in the ground as wide as a man's fist, with 5 or 6 other smaller holes around it, and so deep that those who went to see them could not measure the depth with their long rods or whatever sticks they had on hand. I will not report other such stories, as almost every land has examples of them. There was a lightning strike that created a kind of well on that hill in Turin, 232. And from that particular and very compelling observation, it seems that there follows, as a necessary consequence, another very luminous proposition, namely, Proposition 15 feet. The terrestrial bodies that are unequally electric with respect to one another are certain bodies buried underground at a considerable depth, 234. Because electric fire universally strikes from relatively abundant bodies and is lost in relatively deficient bodies. Lightning strikes from bodies buried at a certain depth, and in bodies similarly buried it is lost. Thus, the abundant terrestrial bodies, which are like the source of lightning fire, and the deficient terrestrial bodies, which are like the outlets, are buried at a certain depth underground. 235. The commentaries of this academy provide significant examples to demonstrate the truth of this proposition. For the eminent Mr. Francesco Maria Zanotti, a man of all sciences and fine arts, and an incomparable secretary of this academy, describing the observations of 3 lightning strikes, shows how 2 were seen to strike from different subterranean cavities, and 1 from a well, from which he, with no less penetrating ingenuity in investigating the truth, and with his golden style in representing it, draws the most opportune conjecture that subterranean and especially humid places are likely to produce lightning. 236. But it is also useful to delve even deeper and more broadly extend our investigation into the electric fire launched underground to bring us ever closer to the cause. For it flashes from one place on earth to another, thundering and striking, circulating through Proposition C16, some significant alterations that occur underground with a direction towards the atmosphere, particularly during storms and violent electrical tempests, suggests that the storm is a circulation of electric fire through the atmosphere, which happens in conjunction with some imbalance of the underground electric fire. 237. I find various accounts of sudden and violent floods that occurred in different countries during storms, and after the striking of lightning, caused not by rain, but by water that surged from the innards of the mountains through newly opened channels. 238. The catastrophic flood that in October 1755 caused incredible damage to the fields of many valleys and made the Po swell tremendously in Lombardy was preceded and accompanied by horrendous thunder, and was largely caused by water that suddenly and in immense quantities surged through new openings from within the mountains. 239. This connection between the eruptions of underground waters and certain extraordinary rains shows, as the most esteemed Mr. Beccaria has hinted in passing, that it is truly ridiculous for certain presumptuous individuals to mock the sacred history, where it attributes the flood to precisely excessive rains and to extraordinary eruptions of underground waters. Nature itself in that regard avenges the pride of man against the workings of divine providence. 240. This same connection seems to further demonstrate, which is pertinent to our purpose, the dependence of those effects on a common cause. Now, the cause exciting the storms, since it is the imbalanced electric fire in the atmosphere, will follow that such an imbalance is connected to some imbalance of the underground electric fire. 241. Indeed, similar storms accompanied by underground eruptions are preceded and accompanied by unusual lightning and thunder. That is to say, by a different movement of electric fire through the atmosphere, and precisely a corresponding or even greater movement of electric fire that occurs underground will be very conducive to exciting that movement through the atmosphere. And if it is violently intense and occurs through the underground waters, it will be very conducive to breaking, as lightning does, the sides of the mountains, and to striking and pushing out through new openings the sudden devastating floods of water. 242. And finally, allow me here, most esteemed Mr. Beccaria, to draw upon my present need a few opportunistic observations from the lengthy definition provided by Richard Valvassor of Lake Zirknitz in number 191 of the Transactions of the English. In the mountain named Javornik, there are two holes, or chasms, which he describes as of exceptional depth. In another hole called Slavenza, the local people believe that witches hold their assemblies, because sometimes certain lights resembling fires are observed there. At the summit of this mountain there is a hole of unknown depth, from which often a noxious vapor escapes, which is supposed to bring storms of lightning, hail, and thunder. For this reason, the priests of Zirknitz go to the hole in procession on Pentecost Monday and perform a certain form of exorcism. There are many other wells in this lake, such as Slednenza, Malabonarza, and Velhabenarza. Vilia and Malabonarza, in the language of Carniola, mean the big drum and the small drum, nor is it without reason that these two wells are called thus, because when it thunders and lightens, one hears in those two wells as if there were the sound of many drums, which I heard with my own ears in the year 1683, thundering 3 times successively, and the sound of the drums responding in harmony. In October 1685, I rode across the lake to the island of Vornek, in the company of 2 old men and practical fishermen, when suddenly the cave in the mountain of Slavenza began to exhale and emit thick vapors, which formed a cloud, and the fishermen warned me to hurry, for undoubtedly those clouds would bring a storm. They had hardly finished saying this when it began to thunder and lighten horrendously, and I had difficulty persuading the fishermen to accompany me to the well Velkabubnarza, as I wanted to examine what is said about it, that when it thunders, one hears the noise as of many drums. This I tested 3 times, and it happened, as I have just told you. 243. Here are the reflections that present themselves to me regarding that account. The opinion of the people, the annual procession, and the personal observation of the reporter aim to show that that place is particularly suited to produce storm clouds to do so. The lights observed in that hole are not very naturally thought to proceed from the exciting electric fire which directs the storms, and therefore must have either a particular conductor or a particular outlet. The clouds do not thunder immediately upon their first appearance, because the electric fire initially does nothing but expand in itself, form them, and push them away from the particularly electric place. When they first approach other clouds and expand over other parts of the earth that are unevenly electric, then the circulation of the electric fire will begin to take place, and then it will start to thunder and strike lightning, and finally, the thunder of many drums, which proves the correspondence in question, is certainly not merely a reflection of the thunder, for if that were so, the author would not describe that thunder as originally proceeding from those holes. One hears it as if there were the sound of many drums, nor would he describe it as so portentous to investigate it further and enrich against the perception of the fisherman. And he would certainly have noted that thunder took time to be heard after the thunder, a suitable time, just as everyone knows, that the voice echoes from the bottom of a well. Now, if that thunder is truly excited in those holes, certainly the exciting cause must be connected with the movement of the electric fire thundering in the atmosphere. And I see no other cause that is better suited to produce that underground sound corresponding to atmospheric thunders than an imbalance of the electric fire that occurs underground in accordance with the imbalance that occurs in the atmosphere. 244. But from the same account, one can also derive another more valid conjecture. The particular wonder of the lake which you describe is that for the greater part of the year it is full of water, but those in the middle of June drain underground through many large holes that are at the bottom, and in September they refill through the same. And around that, the relator states that the waters reflect more abundantly and reflect through a greater number of holes, and they spout to a greater height in proportion to the more impetuous and more continuous rains, especially when accompanied by thunder. And after noting that sometimes the lake fills in 24 hours, sometimes in 18, and sometimes takes 3 weeks to fill. But this is, he concludes appropriately for our purpose, a constant offering, that the thunders and the lightning greatly assist in filling the lake quickly. And since electric fire certainly does not contribute to such an effect, in that it merely thunders in the atmosphere, he wishes to conclude that it corresponds with a subterranean imbalance corresponding to the atmospheric imbalance. And with a subterranean operation, because electric fire indeed operates when it is unbalanced, corresponding to the atmospheric operation, 245. Although none of those conjectures has complete and immediate evidence, I still find enough in their form to seem sufficient to dispel some common prejudice regarding the circulation, which I have elsewhere, and in another letter, linked with the pure phenomena of temporal electric fire. And I have that immediately confirmed with the phenomena, primarily of the lightning electric fire. 246, indeed, until now. The globe of the earth has commonly been considered as a common receptacle, in which electric fire is in a perpetual and universal equilibrium. I think such an opinion has arisen poorly from the observation that whenever any electrified body is in contact with this globe, it loses all its electricity. And this opinion has been further reinforced after it has been understood that every motion of electric fire and every electric phenomenon depends on the force it has to expand equally. It has been believed that through this force, and by means of different terrestrial bodies, electric fire would be maintained in an equitable and constantly balanced expansion. 247. I am very well aware, most illustrious sir, that the facts please you particularly, but I also know that you appreciate good reason when it is coupled with them, and therefore against that common prejudice which the facts I have thus far presented oppose, both regarding the atmospheric and regarding the connection of the subterranean with the atmospheric circulation of electric fire. I dare to propose the following proposition. Proposition decetine. The universal diffusion of electric fire in terrestrial bodies and the different ways in which it is diffused in various bodies conspire to prove that it must imbalance itself in these bodies and circulate through them. The loss of all artificial electricity in the fire does not prove that no natural electricity can play in the globe of the earth, and from it expand through the atmosphere. 248. Thus, electric fire is extracted from every terrestrial body. Nature leaves no active principle idle without action and without operation. It seems, therefore, that from merely seeing electric fire diffused through all terrestrial bodies, one must deduce its actual operation, thus its actual circulation. 249. Moreover, electric fire is extracted in different doses from various terrestrial bodies, more so from glassy, refined, sulfurous bodies, at least from metallic and humid ones. And such different doses are contained in these various bodies in a different manner. The scarce electric fire in humid and metallic bodies is very mobile, and can yield a considerable quantity from other bodies and can flow freely. The most abundant electric fire in glassy, refined, and sulfurous bodies, inasmuch as these bodies preserve their nature, is, so to speak, immobile, and obstructs the impetus of the external electric fire and retains it. Furthermore, in all the bodies of the globe, there circulates a series of perpetual alterations, mixtures, compositions, decompositions, dissolutions, etc. 250. Certainly, according to the alterations of the containing bodies, they must alter the quantity and the manners of the contained fire, and this principle alone proves evidently that the subterranean electric fire, corresponding to the perpetuity and variety of subterranean alterations, must circulate perpetually and with infinite variety corresponding to those varieties. 251. It would be very foolish for someone, seeing that nature and all bodies are endowed with electric fire, and that they are endowed differently, and that other bodies have distributed it abundantly, to think that some are suited to yield an immense quantity, while others are suited to receive it, those that are suited to conduct it, and those that oppose its loss, etc., to believe that nature has devised such an extensive system regarding this operative principle solely to leave it idle and to preserve it for another effect for many thousands of years. Because then, in that century, we began to take from it in our cabinets some empty space. 252. Nor should it be inferred that, because every artificial electricity is lost in the fire, no natural current of electric fire can excite them, and flows so abundantly in the terrestrial realm. The parity is as disproportionate as the tenuity of art is disproportionate to the vastness of nature. The ease with which a current of electric fire is lost is proportional to the smallness of the current, and to the quantity and aptitude of the conducting bodies. A man who descends from the chain to the fire usually loses all electricity, but if the electricity is vigorous and the fire dry, it tends to spark on the fire. If I touch with a single finger the wall, spreading in silence, and without realizing it, all the fire that I receive from the chain, the conducting wire strongly electrified by clouds, however, in contact with the wall, does not cease to spark towards a foreign body, communicating with the fire and to shock it. Indeed, we see how an infinite number of very different bodies distributed along the surface of the earth, and vast torrents of rain do not fail to conduct from a few clouds the electric fire so distributed, that it does not form particular currents in the most different bodies, such as the metallic ones, and therefore does not flow. Nor do the lightning dissolve it. And why then do we think that subterranean humidity and others, through other scarce subterranean conducting bodies, should prevent the most abundant subterranean fire from being present precisely in torrential valleys, and not flow through the most different fissures with an impetus proportional to the density? 253. But once again, I will have the opportunity to speak again of those subterranean imbalances of electric fire, of the unequal electricity of different terrestrial bodies, and of the atmospheric circulation, which, as the phenomena have shown, must result. It is now necessary that I return to reason more particularly about lightning, which, however, I will not do, except in another distinct letter, confirm my most precious benevolence, and I remain your humble servant, etc. Chapter 14. Letter 14. Beautiful accidents and effects of lightning, 254. I would not offer, most honorable sir, to discuss this not new matter, if it were not to bring about much improvement to the things already mentioned regarding it, and to investigate many aspects experimentally that are entirely new. In which case, however, if I were to risk too much in my assertions, I would indeed regret occupying your time in vain. But I could not help but take pleasure in the benefit that I would derive from the effect, and illuminate your judgment. It is this consideration, above all, that encourages me to proceed further and to continue the series of proposed inquiries. Proposition 80. Lightning sometimes gradually opens a path for the series of bodies, the sum of which forms a path that is mostly resistant or minimally resistant, and always travels along the path of such a condition. 255. When I cause a spark to pass through some resistant material, for example, through metallic earths enclosed in glass tubes, if the spark does not have a force sufficiently proportionate to overcome such resistance, it takes a noticeable amount of time to break through. After I have approached the conductive arc, however, as soon as a particle of the spark begins to pass through the small voids present among the particles of the powder, that hissing sound increases, and then the spark follows, which, as we will explain, operates through the powder. If the experiment is conducted in the dark, the hissing corresponds in place of the powder, and at the end of the conductive arc, a faint light appears which increases just as the hissing increases, and finally becomes a sparkling light in correspondence with the sparkling spark. 256. A similar progression of hissing with faint light, then of spark with a sparkling effect, occurs when I gradually bring a finger close to a strongly charged conductor. 257. In the Anglican Transactions, Dr. Wallace, describing the effects of many lightning strikes, one of which killed 4 harvesters, states that before the spark of each lightning strike, a great hissing was heard in the trees, like that of wind. 258. I have often immediately after the spark heard a violent hissing, and sometimes my conductive wire began to hiss more strongly before the lightning spark struck between it and the ground wire. 259. Now that such hissing proceeds from the lightning material, which is in a certain way opening a path towards the terminal that attracts it more strongly, there is no room for doubt that such a path opens more easily through the more resistant medium. And this is consistent with every principle of motion which occurs due to an expanding force equally, and the effects manifest this. 260. Indeed, Everyone wants to recount stories of lightning, and everyone wants to direct them and move them at their will, and usually not without strangeness and astonishment. But in those lightning strikes, all of which I have observed the effects, all of which I have observed, I have seen the aforementioned simplest law precisely observed. I will cite some of these observations. 261. In the autumn of 1753, I observed a tree in the mountainous area of Mondovi. It was the tallest, most leafy, and most pointed of all those in the vicinity. The lightning struck at the top and along the trunk, where some fissures appeared in the bark, and in the wood of the tree, where the more copious fire opened a path that was not indifferent, but certainly less resistant. Indeed, those fissures were absent towards the base of the tree, but this did not occur because the lightning fire had abandoned the less resistant path. Rather, it was because it struck in many more convenient paths, which presented themselves through the bodies of no fewer than 8 children who had taken shelter under that tree, all of whom were struck, and some burned and stripped of bark in those parts where the various branches of the lightning had struck. 262. The following year, I was led to observe the effects of a lightning strike at the Cascina Verna. First, I saw that the 3-story building towered over the other nearby prominences, houses, and trees. Then I clearly observed that the lightning struck at the sharp peak directed towards a tin channel, which surrounded the building at noon and to the east. From that channel it divided into various branches, some of which passed through various nails of a wooden railing. Some of these had pierced the beams and struck down a considerable part onto a man who was holding a child in his arms on the same railing, and thus the force of the channel, which had struck him, killed him, leaving the child alive, because on the man's chest it had not struck more than what could escape through his feet, and thus conducted only through his body from then on. It had so effectively divided that it caused no further harm to many people who were on the ground. 263. Another lightning strike hit the chimney of a house, which is the most prominent in the village of Pau on the eastern bank of the river. The thunderclouds, which I was observing, were moving from the west against this hill. The prominence of the house and the rarefied air above the chimney must have opened a path quite conveniently, and throughout its progression the lightning was indeed passing through more resistant bodies. It was split along a series of nails, along a strip of gilded paper, along the handle of a pan, passing through an iron ring, had driven the nails in, stripped the gilding, and universally magnetized the other metals and on the ground. It had also exerted such force that it struck down through 3 women, and severely injured them. 264. The victim struck by lightning this year was on a rise of the bank of Pau, clear of trees and other resistant bodies. The lightning passed through him from head to toe, and even in such a simple strike, it demonstrated its nature of spreading through the most resistant path. For indeed the skin along the back, along the sides, and the legs was scorched and burned, and there was visible mud scattered and represented. The entire body was so rigid, except for the arm, through which the lightning had not passed. And therefore they remained quite flexible, and so inflexible that a man, taking him by the shoulders and trying to lay him down on the ground with his heels, lifted him upright without him bending even a little or at all, as if he had lifted a trunk. These observations certainly prove that the lightning had propagated through the parts of that body that were most resistant, which are the liquids, the path of its descent. Thus, it had scorched and charred the skin, so fiercely had it dispersed the mud, and spread and diffused, and had so thoroughly dried the affected area, that it had completely hardened and stiffened the muscular tissue. If anatomical observers had examined such a body, I believe they would have at least found the said muscular tissue beautiful, and prepared for the scrutiny of ichthyology. The third. But one effect that the lightning had produced in that body, which is unfortunately detrimental to the anatomical observer, is that there was a branching of a certain muddy vein which spread from near the clavicle of the ball towards the breast, and was so well defined and colored by the lightning down to its tiniest branches, that nothing could have done better than the brush of an anatomist. Some particles of the lightning had diffused along that branching, and had so adhered to its direction as if through unfortunate circumstances, it had found a path so proportionate that, without significantly altering the lateral parts, it had left an effect that was cold in the dispersed mud and represented. I recall having read a similar detail in the Anglican Transactions 265. And from the series of these observations follow, as necessary consequences, many other proportions. Proposition 19.4. The bodies most preferentially conducting lightning are primarily metallic, then humid. Lightning will pass through metallic bodies preferentially over humid ones, and through humid bodies preferentially over any other dry body. Thus, any dry body will be traversed by lightning preferentially over humid bodies. 2. This single proposition would require a more extensive treatise if one wished to present all the proofs and observations that can be gathered on it. I believe it will be sufficient to add a few examples, those that first present themselves. I say add them because from the observations already given, it is already quite clear how lightning prefers to pass through channels, nails, gilding, and all other metallic bodies, and how after these it seeks humid bodies, plants, and humid, and courses especially through their moist parts. 267. Therefore, first, I will add the most excellent observation of the ever-famous Franklin. A lightning bolt in Newbury, New England, shattered a wooden pyramid 70 feet high, which served as the summit of a bell tower. It then propagated along a thick iron wire, as thick as a finger, which was attached to the hammer of the bell and communicated with a clock situated 20 feet below the level of the bells. This iron wire was melted, except at the extremity, and the tower along the entire length of this iron wire suffered no damage. From the extremity of this iron wire, or rather from the pendulum of the clock, which was as thick as a goose feather, there was no damage. The tower was split and excessively damaged. Some stones had been dislodged from their foundations and thrown away at a distance of 20 to 30 feet. From this example, it is indeed manifestly seen how lightning leaves the tower to conduct itself through the iron, and where it conducts through this, it spares that. 268. I find few records of lightning from which facts cannot be gathered similarly with confidence. I will add only two regarding similar iron wires applied in bell towers. The Anglican Transactions, describing the damage caused by lightning in a bell tower in Stralsund in Pomerania, note that both the iron and copper wires, as well as the hammers of the hours and quarters, were partially broken, and then that the rest of them could not be found, etc. 269. The other example I draw from the golden commentaries of the same academy, where the incomparable Zanotti speaks of the lightning that struck the bell tower of St. Christina. For the monks, I present to you the original description, or rather painting, which I cannot translate without losing its value, stated that they saw a single path, through which a long iron wire was drawn to the bell from the lower part of the building to be propelled, and that the wire was almost entirely consumed. Only the extremities remained, which, where they had been consumed, formed sharp points, polished almost like a file. The whole form of the wire had been struck by the lightning. 270. The other parts of the proportion are sufficiently proven by the observations, part of the previous proportion, and they can be validated with what I have said elsewhere about the aptitude that wires have to conduct the fire of clouds. One can bring forth as many convincing proofs as one wishes. For a charge of many glasses will discharge through the wooden path from the tips of a metallic leaf, preferentially over any other body, even humid, and thus I pass directly to another no less useful proposition. Proposition 26. A lightning bolt propagates in many branches proportionally to the amount of its fire, and proportionally to the number of conductors that it encounters, and in each conductor, it generates a quantity proportional to the aptitude that it has to conduct it. 271. There is nothing more common than to see the lightning divide into many branches through storm clouds. Many times I have also seen a lightning bolt distribute itself so divided over various rooftops, chimneys, and other projections. 272. Was it not the case that the lightning struck the tree of the monastery and then branched out into as many parts as there were children struck at that moment? 273. But what other proofs? Whenever lightning strikes, is it not true that for all the terrestrial bodies subjected to the cloud that either strikes or is struck by lightning, It discharges a quantity of fire proportional to the respective aptitude that they have. Is this not evident from the observation that in every strike of lightning, the signals of my conducting wires are altered, and in proportion as the lightning is more violent and less distant, these alterations are stronger, so that sometimes they consist of luminous sparks, thunderous and truly fulminating, 274, and greater alterations of such kind occur proportionately in the wire of the pyramid than in the other, more distant one below. And it is observed that generally metallic bodies, and then humid ones, are preferentially struck over other bodies' previous proposition. These are facts that altogether show that they are entirely contrary to the common opinion that lightning is a single, indivisible current of devastating matter. It is a vast torrent of electric fire which divides and subdivides into as many streams as there are conducting bodies that it encounters in its path. Circulation, and it spreads in any body in proportion to its capacity. 275. When I consider these things, I cannot help but admire the boldness with which some observers of lightning effectively conduct a fierce lightning bolt through 1,000 twists and turns, seemingly taking pleasure in doing so leisurely and calmly visiting the rooms, and the reports of their paths, noting where it struck, where it bent, where it rose, where it re-entered, where it disappeared. For I see quite clearly that these are the various branches of the same lightning, distributed regularly according to the aforementioned proportion, which they have in striking all the different objects, to which they would like to be directed through 1,000 tortuous and irregular turns, successfully dragging the unique, indivisible lightning, 276 dites. But regarding the direction and distribution of lightning, let us turn to the effects, and first we shall see how they open the path through the resisting medium, proposition 21. Lightning, in proportion to its density and quantity of fire, tears away the parts of the resisting medium, and also of the bodies conducting it, and throws them out, distributing them in the resisting medium through which it must pass. 277. The perforated cardboard from a spark, the walls perforated, and universally the building struck by lightning, are all evidence of the force with which lightning tears away the parts of lime, bricks, stones, rotten wood, and universally of the resisting bodies, 278. Elsewhere I have already sufficiently demonstrated how lightning tears away the resisting air, so there is no need to say more about it. 279. And the metallic leaves torn away, the streams of water pushed away with great force and evaporated by the spark, and the iron wires torn by lightning sufficiently prove how the electric fire, in proportion to its density and quantity, also tears away and scatters the parts of the conducting bodies. 208. But the law particularly must be noted, with which those torn parts are scattered and distributed. This law I present before the eyes of the interested with immediate experimentation. Consider that by discharging a large glass and strongly charged, through a thin strip of silver leaf placed between two sheets of wax, and of such length that on one side it protrudes outside the sheets to touch the armature of the glass, and on the other side does not reach the end of the sheet, but remains within some line, then the spark discharges a sum of metallic parts from the brass ball of the conducting arc, and those tear into the sheets of wax and embed themselves in the place where it is missing, or even where the silver leaf is scratched. That is to say, they are distributed in the resisting medium through which it must pass, and they form a colorful conducting path. 281. Sometimes the parts of brass thus torn by the spark have penetrated quite deeply between the sheets, even reaching the other end to continue the path of the thin strip of silver, which had some small accidental interruption. 282. I think I must attribute to a similar cause a particular and not dissimilar accident. One day I was holding a strongly charged glass, and with the other hand a carafe full of nitrous spirit. While I presented the tip of the glass to the smoke that spontaneously issued from the carafe, a strong spark shot from the hook towards the articulation of the thumb of the other hand, and opened a small, angular, but painful wound in my skin. That spark, as far as I could judge, broke from a distance of at least 4 inches, and the inflamed wound certainly must have proceeded from the nitrous smoke, which the spark had attenuated into a very subtle breath and pushed along the long path, and struck against the skin, 283. And all these experiments suggest to me a much more complete and determined explanation of the flash and the thunder than those we have so far presented and derived from the consideration of the simple ordinary electric spark. Proposition 22. Where the largest current of electric fire is exceptionally dense, a large part of it tears away in straight and direct paths, from which it pushes away the air, and thus presents the appearance of the shining flashes of lightning, 2T5. Probably the electric fire so dense also expands in thin, transparent breaths, some part of the cloud, through which it pushes and disposes those breaths in the aforementioned ways, as if to expel the air along the longest paths. The thunder is nothing but the almost instantaneous snap of an almost instantaneous discharge of long stretches of air. With respect to the hearing of man, the thunder makes a successive, prolonged rumbling due to the varying distance that seems to exist between the person who hears and the various parts of the long stretches of air pushed and torn away. 284 regarding the first part of that proposition. It should be primarily noted that the flash is nothing but the appearance of the most dense part of the current, which indeed floods the entire body of the storm clouds, as evidenced by the high ratios of the signals that occur in my conducting wires while a flash occurs, even though it is distant, 285. The force that always animates the electric fire to spread equally also animates it to spread through the shortest path towards the terminals that it strikes, and it animates it to spread in greater quantity towards the terminals that it strikes more, and that is the reason why the largest current, due to some strokes, becomes denser and shines more brightly, 286. That, then, the air from these luminous stretches is pushed away has been demonstrated elsewhere, 287. It will be more useful to consider the length of those stretches, which we have seen extend for more than half a circle of the visible hemisphere. And it seems to me certain that any sufficiently large current of fire can only push away the resistance from such long stretches and instantaneously traverse them without procuring any particular conducting medium. All electric movements show how the electric fire tends to distribute the conducting particles in its path, and the experiments presented in the previous proposition demonstrate how strong sparks detach very fine metallic particles, and tenuano, the vapors of water, and those that they emit and distribute along their path, thus reaching great distances. Therefore, in accordance with its dissolving nature and consistent with the experiences presented, the striking electric fire must attenuate and expand the cloud of vapors in such a way, just as common fire does, and it must scatter them over long distances, occupying them, and through this, pushing away the more gross vapors and the resisting air, 289. I do not wish to reflect on the rapidity with which such phenomena occur, without regretting the manner in which I have explained every successive rumbling of thunder too universally in my book, considering then all the temporary clouds that are distant, and placing in their singular occurrence all the temporary functions. I thought that the successive sounds proceeded from the singular occurrence of those clouds, and from other distant clouds that are unequally electrical, which explanation I now find insufficient, just as the principle from which it derived. The electric fire unites the clouds to play through them, and after they are united, then it must strike, and the phenomena to which long and enduring thunders correspond are very rapid, as shown by their appearance and the corresponding alterations of my signals. Therefore, there is a single way to explain how such a rapid effect can be so enduring, and such a manner guiding the successive propagation of sound is absolutely necessary, because being extremely long, the stretches of air are instantaneously pushed away by the phenomenon, and each part of the vibrated air excites a distinct wave, and rendering differently distant from the ear of a person. The various parts of those stretches, although all the said waves are excited in the same instant, will only reach the ear successively, that is to say, first the nearest, and then the farthest. According to the greater interval of time, that sound requires to propagate itself over greater distances, 290. From this it follows that in every thunder coming from a single phenomenon, we will begin to hear the portion coming from the nearest place, and successively those coming from more distant places, which fact, although it may seem strange, I have not found contrary to observation. Furthermore, in this observation, I had to employ two considerations. Firstly, I reflected that however the unity of sound reflects to our sense decreases proportionally to the distance of the one hearing from the origin of the sound waves, yet it increases also proportionally to the force exciting the waves, so that it often happens that this increase overcomes that decrease, and consequently, although at times a part of the phenomenon may have had from its force a greater activity in shaking the air, then its greater distance has to weaken the perception, the portions preceding the thunder and coming from the nearest place would excite a weaker perception in hearing than the successive portions coming from a more distant place. 291. I had to consider, secondly, that indeed a single and instantaneous phenomenon excites a long thunder, but that sometimes the thunders of many phenomena complicate together, succeeding one another, now more, now less promptly, and sometimes even with different directions, so that the perceptions of various thunders become incredibly complicated. 292. And those few things I say about the phenomena that occur through the clouds, and the corresponding thunders of the phenomena that pass between clouds and the earth, which I distinguish with the name of lightning. I wish to reason similarly that they are nothing but the beginning and the end of true phenomena, and the particular considerations that one wishes to make around them, I have boldly hinted at, so that from the immediate appearances and accidents of those, I will now proceed to unveil others and other effects. Proposition 23. The lightning, just like common fire, evaporates, ignites, vitrifies, calcines, magnetizes, and probably metallizes the bodies that can respectively evaporate, ignite, burn, vitrify, calcine, magnetize, and metallize. There is this difference between common fire and electric fire, that the latter produces in an instant the said alterations, which the former does successively. 293. The evaporation and ignition produced by lightning. Indeed, by the sparks I have spoken of sufficiently, of the burning of more solid bodies. I will bring forth a single example from number 177 of Anglican transformations, where it is read, which lightning set fire to the bell tower, I cannot say, but a piece of wood, to which the lead covering the windows was nailed, was set on fire and burned very quickly. 294. Besides the vitrifications of metals, made with the sparks first by Franklin, I have vitrified borax powder, just by my method, inside a small tube. The white borax powder, opaque from a strong spark, becomes a united, transparent body, adhering to the glass of the tube because the spark in its passage also melts the surface of the glass, as can be seen with a lens, and sometimes even with a lens. Shortly I will speak of certain sand vitrified by lightning. 295. Inside similar glass tubes with a spark, I have calcined a small amount of powder of casting metal. 296. And since all those effects are similarly produced by electric fire and by common fire, I think that if the operation of electric fire is applied to metallized metallic earths, in the same way that common fire is applied, then both analogous agents will converge in that. For that purpose, I have published a certain flying paper in which I spoke of rendering with electric sparks a metallic appearance to metallic earths. I then operated with moderate sparks, and on very small portions inside narrow tubes. And I used earths, such as clay, which contained some residue of lead and not of lime. The burnt lead was not perfectly calcined. From the powder of that, I then obtained a small stain inside the tube, which has consistently seemed to me to be the color of lead. From the powder of copper, I obtained a small, shiny stain of a bright red color from Martian crocus. I obtained a stain of a ferruginous color and one of a leaden color from lead litharge, 297. But unfortunately, the small, too red and bright stain of copper misled me, considering that that color rather suited the glass of copper. I experimented with stronger sparks, sealing the tubes with a piece of paper so that the spark would not scatter the small pieces, and I saw more manifest effects. Because the stronger spark, which I made pass through the lead litharge, left in the middle of its passage a stain of a yellowish color, similar to amber, which is the color of glass of lead. From the copper I obtained a strikingly bright red stain, but proportionately larger, which I could discern more clearly through a glass of copper. I experimented with antimony lime and obtained a yellow stain, which is characteristic of antimony glass. From the crocus of Mars I indeed obtained some iron-like stains. However, I saw that the darkness of these stains arose from the gas developed, and that their apparent brightness came from points on the inner surface of melted glass. 298. You will recall, most illustrious sir, that as soon as I sent you the flying letter, I immediately wrote to you about my further observations, before you addressed me with your otherwise prompt, most humane and astute response. I practiced the same office towards others to whom I remembered having sent that letter. Moreover, I believe that the form of those experiments is of some significance, primarily because they increasingly expose the vitrifications of metals produced by the spark, and secondly, because they indeed lead us to explore the metallization of metallic earths, which can only be produced together with vitrification by the unique force of electric fire, just as common fire melts and vitrifies metals, and truly metallizes the earths. 299, in fact, in the lead vitrification. I observed that the little yellowish glass was surrounded by a small edge of a color almost like lead, and universally I saw that the small portions of vitrified earths were similarly surrounded by a variably dark edge. Now such a color of the edges certainly comes from the gas, which the spark must expel from those parts in order to vitrify them, and that gas which, abandoning the struck parts, must proportionately metallize the lateral parts against which it is driven. 300. In accordance with those principles, I collected lead oxide, and in the broken tube, I observed with a lens some tiny lead pellets, soft, adhering to the glass near the point of impact, which I did not see in the simple lead oxide. Also, in the struck copper, I similarly observed tiny pellets which, when viewed with a sharp lens, appear to be true copper. 301. In order to obtain more conveniently observable effects, I attempted another experiment. I sprinkled copper powder over 2 sheets of wax. On top of them, I placed a thin sheet of tin. I hoped that the gas expelled from the tin sheet and driven into the powder would not present any change suitable to my intent. 302. As no experiment in itself is ever in vain, this one also brought me some insight and presented me with a rather joyful spectacle, for the spark, at the moment it passes through the wax, renders it entirely luminous internally. And furthermore, I did observe some alteration in the mentioned powder, but not such that I could certainly conclude from my purpose. 303. The annoyance and difficulty encountered in procuring larger sparks, and the method that presented itself to me for obtaining them without further effort, despite their considerable size from nature, led me to abandon every other attempt. And this year, when I was just thinking of executing the contemplated method, I found myself very busy attending to those particular effects. So for now, I can offer you nothing but my regrets. 304. I had thought to erect a very tall antenna in a wide open field to isolate its metal tip with the highest and most suitable glass I could procure, so that lightning could not discharge into the antenna, and also for this purpose, I had contemplated covering a large part of the top of it with a suitable malleable material. From the tip, which with a suitable cover would protect the glass from rain, I would lead a thick metal wire under some tin. To that wire, I would attach a thinner wire, about a foot long, which I would wrap with various metallic powders enclosed within 2 half cylinders of wax tied with thread. To that thinner metal wire, I would attach another thicker metal wire. I would attach another, which I would bury deeply in the ground. I hoped that the considerable height of the tip and the ample insulation of it and of the wire in relation to the antenna, and the connection of the wire with the ground, would lead to true and frequent lightning passing through the wires of different thicknesses, proportionately to the capacity of the thicker wire, which would spare the thicker wire, and allow the thinner one to be illuminated, that the gas expelled from the thinner wire into the adjacent powders would illuminate more clearly around that question of metallics and metallic earths with electric fire. That if any light around this would arise from that manner of experiment, it would certainly serve to investigate further the infinite effects of lightning. 305. Regarding the attractive force that lightning possesses, we have abundant evidence. Franklin was the first to attract sewing needles with the spark from large glasses. Dalibard noted that the end of the needle, where the spark enters, points north. Franklin and Dalibard similarly observed that a second spark of equal intensity, but in the opposite direction, disrupts the direction indicated by the first spark. And I, in replicating those experiments, considered that they are a very evident proof of a large part of electrical theory, namely that electric fire moves with a single determined direction. For if they move with opposite and equal directions, it would not make sense for the needle to point to the pole more strongly with one end than with the other. And much less would it make sense for an equal spark passing through the reverse needle to extinguish the force imparted to it by the previous spark. 306 in the English transactions, 3 cases of lightning are reported, which have reversed the direction of the needles in the compasses of ships. An accident, if unnoticed, can cause considerable damage, and at the very least should lead to navigation being reversed. As happened to a ship in reverse from 3 in the afternoon until the appearance of the stars, Captain Edward Ladd, in whose ship Albemarle the compass was struck, and the direction of the needle reversed. 307. The cause of such reversals is manifest. The effective force of lightning, besides destroying the direction of the needle, must induce a new one. 300. Similarly, the English transactions report a lightning strike that, having struck scissors, knives, and nails enclosed in a box, attracted them to such an extent that when lifting the knives, they pulled the nails behind them and held them. I have 2 pieces of a circle of a struck iron that have been affected. Both have their poles. Both are soft. A lot of iron filings. 309. Not only iron, but all bodies susceptible to magnetic virtue are found to be magnetized by lightning. I have already briefly mentioned the piece of brick magnetized by lightning that struck the tower of the Esmeli. It is a triangular piece of brick, rectangular in shape. On one side, it is 5 inches long. On the other side, it is 2.5 inches wide. And the third side is precisely the diagonal. One of the triangular ends terminates at the height of the entire brick. On the other side, various pieces have been chipped away. The lightning has indeed vitrified the sandy material that was found adhering to the side, without any other visible alteration in the structure of the brick. The vitrification forms a sandy material that is joined together 3 inches wide at one end, 1 inch high at the other, and 5 lines at the opposite end. Moreover, such material is scattered with tiny vitrified bumps, which are probably the grains of sand that are more and unevenly prominent. The entire vitrification is shiny and transparent, with the main part being a dark green color. Only the prominent bumps are, like the moss, light green. In summary, the characteristics of that vitrification seem to confirm what is otherwise clear from the fact that it is produced by such an instantaneous agent as lightning. Now that brick is magnetized and it has its poles, or rather 2 poles, one northern and one southern, because the long side of the entire base presented parallel to a small magnetized needle attracts the northern pole from a distance of 5 inches, and the other long side of the base attracts the southern pole. Even all 3 parts of the brick affect the needle, but the 2 sides containing the vitrified sand affect it more than any other part. From this, one must conclude that the main part of the lightning has passed through the area of vitrification, that it entered precisely through the long side corresponding to the entire base, and that it exited through the opposite side. And here is the only way, for now, that presents itself to us to resolve a question that Franklin has proposed as most important to the amateurs of electricity. Proposition 24. We must determine whether a given lightning strike descends from the clouds to the ground, or from the ground to the clouds. 310. From the preceding propositions, it is evident that lightning must primarily strike metallic bodies. The poles of the aforementioned brick demonstrate that even in certain bodies that contain a certain amount of iron, lightning leaves a permanent mark of its direction. Mr. D, Buddis, professor of the Royal Schools of Essex, sent me a struck green stone shattered and magnetized. Thus, it affects the needle at a distance of 5 inches. Therefore, when one wishes to investigate the direction of a given lightning strike, one must first check if there is iron in its path, such as brick, ironstone, etc. Then, with a magnetic needle, one will explore whether such bodies have received northern polarity on their side facing the ground, and southern polarity on their upper side. And in that case, it will be concluded that the lightning is coming from the ground. If the opposite is found, the conclusion will be the contrary. 311. Here is an example. This year, on the feast day of St. Peter, lightning struck the palace of Count Coligno, the reformer of studies. The lightning struck through a railing that surrounds the secret staircase of the palace. All the vertical bars of the railing at their lower part have strong northern polarity. That is, they attract the southern pole of the needle, and have equal but opposite polarity at the upper part. The wall, in which the top of the railing is fixed, is shattered, and the series of these breaks progresses from that top, directly with some inclination to the horizon. From that series of breaks, I obtained a stone similar to the stone of Monal or Buddis, which also has a strong northern polarity at its lower part, and equal but opposite polarity at its upper part. From the top of those breaks, the lightning progressed internally through the wall of an adjacent chimney, from where it shattered bricks, stones, etc. Then it diagonally broke through the grating of an adjacent attic. It shattered and magnetized the iron blades at the appropriate corners through which it entered, producing northern polarity in the lower corner and southern polarity in the upper corner. Finally, it discharged through the chimney, shattering. It discharged through the chimney, vitrifying and calcining bricks, tiles, and other materials. In this progression, since it has constantly imparted northern polarity to the lower parts and southern polarity to the upper parts of bodies, I believe I have rightly concluded that such lightning is coming from the ground. Proposition 25. Explaining the stone of lightning, 312. Everyone speaks of the stone of lightning. Many philosophers discuss it, some even grind it. But the most recent electricians, because they do not conceive its possibility, believe it is right to absolutely deny its existence. I think they do so according to the truth, if by the stone of lightning one means the fulminating substance, which we now at our pleasure conduct observe and experiment with all our senses, is nothing other than fluid and actual electric fire. Independently of those observations, I heard a rough peasant speak very experimentally about that stone, for he was precisely stripping the fulminated tree in Monastero with a knife, and paying attention to the many and very uneven channels that the various branches of lightning had formed in that trunk. He said to his companions, "Look, you who seek the stone of lightning, what beautiful things this wonderfully ingenious stone makes." 313. But although there is not a stone that is the fulminating substance, I believe there are stones that can properly be named and truly be considered stones of lightning. I think that even that common opinion of the populace has its foundation, which consists in taking the effect for the cause. And in fact, is it not true that lightning calcines, vitrifies, and alters in many complicated ways the earth, sand, stones, and other corporeal substances? For example, 100 times more sand than that which I observe in my vitrified brick, and united by lightning, would it not represent a very true stone of lightning? And the elongated, vitrified, and particularly shaped stone, which attests to the Anglican transformations found in a hole excavated in the ground by lightning, is it not a stone so altered, vitrified, and shaped by the fulminating and vitrifying fire? 314. Thus, just as a very small artificial lightning induces alterations in the substances it strikes, which they are capable of, so a natural lightning bolt must induce similar, but proportionately larger alterations, and must present to us not just particular stones, but also various and differently altered bodies. Proposition 2016, to conjecture about the magnetic virtue of many terrestrial bodies, and about magnetic direction. 315. I had had various types of needles made, both of copper, silver, and gold, similar to iron needles, which I had failed to magnetize with the electric spark, and I have similarly struck them with strong sparks, having first filed them vertically, so that their position would be indifferent to any horizontal direction that the spark could impart, Yet none of them, to my surprise, has settled in any particular direction, nor has any retained the force to maintain any particular direction. None has attracted or has been attracted by magnetized iron, nor by other homogeneous bodies. And from this, I've become increasingly convinced that the magnets mentioned by old Ravandi in his Metallurgy are indeed fanciful, to which some attributed the particular force to attract gold or silver, and therefore they named them golden and silvery. The attractive force in magnets and in iron is reciprocal. If there were a stone that attracted gold or silver by its properly magnetic virtue, that is to say, excited by the electric spark, such a spark should also excite it in gold and silver needles with respect to at least golden and silvery bodies. 316. Just as the inefficacy of those sparks leads me to conjecture the fallacy of the imagined magnets, so their efficacy, and much more that of lightning, guides me to conjecture about the true cause of the genuine magnetic virtue of certain bodies that are capable of it, just as lightning has magnetized the scissors in my iron circle, which I mentioned above. So the lightning, which preferentially passes through prominent and metallic bodies, must magnetize the iron of weather vanes, the pins, and the iron rods, such that they balanced the bells, etc. a few days ago. When I went out to the famous magnificent temple of Carignano, I was shown that a lightning bolt had torn away the cross from the top of one of the domes. In descending, I observed that certain iron keys appeared in the vault of the staircase that surrounds the large dome, and that the lime coating had been shattered by some body. I easily detached a rusty iron scale from one of the keys and brought it with me, observing that it was charged with a great deal of iron residue. 317. Just as lightning has impressed the virtue of agitating the needle in the stone and in the brick mentioned above, so lightning must impart a similar virtue in other stones and in other similar bodies. And here, if I am not mistaken, is the reason why certain large masses of stone, cracked and split, so vigorously altered in America the bulge of the most celebrated Bauer. 318. And would not the gentle and almost perpetual circulation of electric fire impart with its subtle operation some weak magnetic virtue universally in all bodies that are capable of it, just as such, although a stronger virtue, in an instant produces the vivid operation of a lightning bolt? My observations show me that indeed a very large quantity of electric fire circulates widely from certain places of our globe through the atmosphere to other different places during thunderstorms, that such a large quantity also circulates during rain, and that even in serene weather some quantity circulates. I think that some part continuously flows through all the filed bodies above the earth, but more particularly through metallic and iron ones. I believe that it is this which, passing through pans, spades, blades, and other such elongated iron objects which usually hang or rest vertically, imparts to them the virtue of situating themselves in the magnetic meridian when they are suitably balanced. 319. An apparent contradiction in the English translations confirms me in this respect. In number 211, they say that the aforementioned irons point north with the lower end, and in numbers 276 and 278, they say that they point north with the upper end. We know that that end must point north, through which the electric fire enters. And indeed the circulation of that fire is completed by going from some place on the earth, passing through the atmosphere, and re-entering in another place. And according to that circulation, and the operation of it on the irons, those in certain places and times will point north. In other places or times, with the same end, they will point south. And universally they will point north with the lower end in those places, and times where the fire that strikes the earth prevails over the fire that returns to it, and vice versa. 320. But moreover, if it is indeed the electric fire that, passing violently, magnetizes instantly or circulating gently, impresses in capable bodies some magnetic direction, would it not do so with some determined, universal, imperceptible, perpetual, periodic circulation, which goes from the northern parts to the southern, universally producing and conserving every magnetic direction? 321. The uniformity constancy. And universality of that circulation would render it indistinguishable, because universally a body immersed in a mass of equally electrified bodies has neither nor gives any sign of electricity. And I myself see certain birds flying high above the electric clouds, where they certainly would not rise, if they had a distinct relation to the particular currents of electric fire through which they pass. We should feel nothing more of that systematic magnetic current. 322. The appropriate measure of that universal current proportionate to the capacity of the bodies and the air itself could contribute to rendering it imperceptible, for they could well be such by nature, disposed in the air and the other bodies, that they would easily translate and lend another appearance to that measured systematic or current of electric fire, and would thus allow for a greater quantity to be translated. 323. Furthermore, such a current should attract iron bodies more easily than other bodies, and therefore attract them, unfortunately, according to their length, and in such a way dispose the smallest openings that resulted, and particular ease for attracting them along the same direction, and the difficulty for attracting them according to the opposite direction. 324. That systematic electromagnetic circulation, in my opinion, would not proceed from a single northern point, but would have infinite sources in various points of our northern hemisphere, perhaps more densely in places closer to some northern point. And the frequency, position, or rather the direction of their bodies would be represented to me by the position, frequency, and direction with which see diffused around the hemispheres of a spherical magnet, the orderly lines of iron filates. And given such hypothesis, the aberration of the center common to all the various sources, which would extend their action to a certain ratio from the true northern point, would explain to me the aberration of the magnet. The period of that aberration would explain the period of that declination. The obliquity with which those sources would emerge from the ground and direct themselves towards noon would explain both the inclination of the needles and the particular ease with which iron is magnetized when inclined in such a manner. 325. In addition to that aptitude which such a circulation would have to explain such phenomena, three reasons present themselves to me as highly probable. The first is that, although the magnetic direction is the same for various magnetized bodies, at the same time and in the same place, it is still different at the same time in different locations, and it is also different at the same location at different times. And those variations, both local and temporal, proceed with a certain regular periodicity, which seems to depend on a composed regular variation of a common underlying moving principle. 326. I derive the second reason from the very simple and most fruitful genius of nature, which draws all composable effects from every active force, and does not hesitate to produce an effect that a principle is producing. Now, the magnetic direction is certainly excited by electric fire, and probably not excited by common fire, and perhaps not otherwise excited by the sparks or by a certain fragmentation of iron, except that in this way iron becomes more capable of conducting electric fire according to a certain particular direction. Thus, I think that universally every magnetic direction is originally produced and is subsequently preserved, and periodically altered by the operation of this electric fire. 327. But finally, the most valid reason presents itself to me from the consideration of the auroras borealis. After rereading the latest edition of the ingenious treatise by Mr. de Moran, and much more after observing in it a particular temporal aurora borealis, I have become increasingly convinced that such phenomena are nothing other than an apparent circulation of electric fire between the northern and southern parts, and thus, with respect to the present hypothesis, it presents itself to me as a visible overflow of the universal, cohesive, uniform, imperceptible electromagnetic circulation. All the other observations I read in the proceedings of various academies present to me. In the auroras borealis, the light, the velocity, the movements, and in a word, all the signs of electric fire, and my own observations make me perceive a striking analogy and similarity in the motion of electric clouds and in the motion of vapors or lightning propagated, vibrated, illuminated in the auroras borealis. Thus, I clearly revive the similarity of the efficient principle. Moreover, as the English translations assure me that temporary electric fire reverses the direction, or even merely alters the declination of the magnetic needle, so the particular observations of the ingenious Halley and the valiant Vargentine lead me to understand that the electric fire which abundantly flows in the auroras borealis disturbs and unsettles the magnetic direction in an unusual manner, that sometimes it changes the direction by 3 or 4 degrees in a few minutes, so that it seems that the declination of the needle follows the declination of the auroras borealis. All these things lead me, as I said, to conjecture from such abundant, visible, extraordinary circulations the existence of a universal, perpetual, periodic circulation that impresses, alters, and preserves every magnetic virtue. 328. Furthermore, I propose these observations to myself, most venerable Mr. Beccaria, not to convince you of them, but to procure for myself, with them, the spirit and energy to experiment regarding that which is important, as much as it is obscure, concerning which I will not hide from you that until now I have experimented without being able to obtain further insights. Thus the cord of 1,500 feet which I have stretched between Valentino and the villa of the missionary gentleman has shown me that the particular electricity of the buried wire which I had arranged according to the magnetic meridian, rather than deriving from the particular position, came from the particular length. My hypothesis also led me to suspect that, if its electric force were the efficient principle of magnetic properties, I might have been able to see some light between the magnet and the needles that were agitated, or the iron that was drawn. But even regarding this, until now every attempt of mine has been in vain. I also thought that just as unbalanced electric fire does not excite movements in a vacuum, while it does in a filled space, so the magnet would not move the filings confined in a vacuum glass as it does in the air, but rather the filings have similarly curled up in that which I had confined in a vacuum glass of air, just as they did in the open air. All those vain attempts, although they are not in themselves absolutely incompatible with the adopted hypothesis, still, for that very reason, since they are vain, and also because they continually limit the means of experimentation, certainly do not discourage me from further experimental endeavors regarding that. And the doubt that my hypothesis may be vain makes me reflect that perhaps I am abusing your humanity by entertaining you about it so prolifically. In that doubt, I do not know how better to resolve myself than to conclude this letter, and to conclude it with another less uncertain, and certainly useful inquiry, which may lead me back to the matter from which I may have strayed too far. Proposition 27, to deliberate on the use of metallic conductors to protect a building from lightning. 329. The tip with the respective metallic wire of the pyramid, and the other pyramidal sections of Valentino with their reflective differential channels, however eminent they may be, since they are at least 50 feet high, and conduct a great quantity of fire, still do not prevent very durable and very impetuous storms from raging over Valentino itself. Besides the fire that they conduct, so much fire additionally surpasses that which can maintain a strong and continuous current in the wire of the attic. Therefore, it is false that one or several metallic conductors could, in a short time, exhaust all the temporary electric fire and thus dissipate the storms. And it is indeed so that they all entirely conduct the aforementioned successive electric fire 330. And since when lightning strikes nearby, strong and thunderous sounds correspond between my differential wires and the corresponding safety wires, they produce strong and thunderous sounds. Number of strong sparks had erupted between my conducting wires and the corresponding wires of the lightning rod. Yet even while these strong sparks were flashing, there was no other sign of electricity. Moreover, the wire of the attic was emitting from various points along its length flashes of brilliant light. That is to say, through those connected wires, the fire was flowing invisibly and without any other sign, accumulating and densifying to overcome the interruption of those 334. Furthermore, more than any other consideration, the immediate observations of lightning show that it primarily seeks to discharge through metallic bodies, and in those parts of buildings where such conductors are lacking, it causes significant damage or even strikes living beings. I am convinced that if they are continuous and have an appropriate thickness, they can be very useful. To these observations, which I have presented elsewhere, I will add only a reflection regarding the Valentino Palace, which is specifically equipped with the aforementioned suitable conducting wires. In the surroundings of Turin, I do not know of any structure more exposed to lightning, whether due to its particular height, the sharpness of the chimney, the pyramids placed upon it, or even due to the very favorable position against storms that frequently come from the southwest. The eastern hill, which is not separated from the Valentino by the course of the Po, is struck by lightning in various places almost every year, and sometimes in the highest areas of the Valentino. I have no memory of the Valentino Palace ever being struck by lightning, or rather, I have no memory of it ever being damaged by it. I believe instead that the lightning discharges in the Valentino without causing any harm. It travels through the pyramids and the connected conductors, thus sparing the structure. This year, although many very frequent and very vigorous sparks have erupted between my conducting wires and the respective lightning rod wires, I think that the portico of my observation was not struck by true destructive lightning for the following reasons. First, because the sharp point of the pyramid and the uninterrupted connection to the ground of the conducting wire, due to the short distance between the conducting wire and the lightning rod wire, should have conducted its electric fire more effectively, which densifies and accumulates, as I said, proportionally to the resistances to be overcome. Secondly, because the aforementioned point was not insulated by glass, which was only a small gap of 5 fingers. Thus, in the case of a more copious current of electric fire, a large part of it should have discharged through the pyramid and the connected channels. And thirdly, because a large of the electric fire has always had to be divided into the other sections of the pyramids, which were all slightly lower than the aforementioned point, and in a certain way surrounded it. I inform you that I am not skilled enough to convince myself that a factory equipped with metallic conductors like Valentino will not be damaged by lightning. 2 electric velocities in atmospheric electricity, 335. In Turin, many buildings are surrounded by open tin channels, which conduct water to the ground through other closed channels. 2, 3, or 4 metallic points erected above the ends of the chimneys and connected to the aforementioned channels by a wire of approximately 3 lines in diameter would sufficiently protect these buildings from lightning. I mentioned 2, 3, or 4 points because although I believe that a single-pointed conductor with only one large wire, as previously mentioned, could conduct a truly horrendous lightning strike, I also see that a metallic point can attract the fire from a cloud from a great distance, as demonstrated by the visible electricity in the wire of the attic, when I extract a spark from the wire of the pyramid. Nevertheless, I believe that the number of points should be proportionate in some way to the size of the buildings that need protection. A single conductor will adequately protect a bell tower, a tower, or a ship. 2 conductors will sufficiently protect a section of a building, even if it is 200 feet long, if they are applied at the ends. 3 will protect 2 sections of equal length, applying one at the corner formed by the 2 sections and one at each end of those sections. Or 3 points will also suffice to protect a triangular building with 3 sections, applying one at the vertex of each angle. 4 will protect a square building by applying one at each corner. I believe that these few examples will help determine the necessary number of conductors to protect any given structure. 336 to determine the thickness. I rely on the observations mentioned above, from which it is evident that the devastating lightning in Newbury indeed melted the iron wire, as thick as a string, but correspondingly spared the tower. And it was then conducted by a wire as thick as a writing pen, sparing the tower and not damaging the wire itself. And probably it would not have even damaged a thinner wire, which was only connected from the base of the tower to the ground. For in such a case, the lightning fire would not have been concentrated and accumulated to such a degree, as it had to accumulate and penetrate to overcome the great resistance of the tall pyramid, and to overcome the even greater resistance of the parts of the tower that were not equipped with another conductor. To effectively translate the lightning material, one must pay very careful attention to the manner of the common connection of the conductors with the ground. It is essential that they communicate with the ground as widely as possible, and that they connect with parts of the ground that are well suited to conduct electric fire. As I have noted, I connect my safety wires to the ground through a wide iron railing driven into the earth. I would consider a similar connection excellent for any conductor. I would also consider it excellent if the conductors were connected to a stream of running water, and in the absence of such conveniences, at the very least, the ends of the aforementioned conductors should be buried and conducted for some distance under the moist earth. Such connections will ensure that lightning spreads promptly. Indeed, the conductors of Valentino are not buried underground. However, the ample and continuous contact they have with the buildings to which they are applied, I believe, is sufficient to distribute the lightning fire so that none of them is struck. 338. Finally, to all those positive remedies relying on the application of continuous conductors, another negative remedy can be added, albeit in certain perilous buildings, which is merely to avoid using other interrupted conductors. For such interrupted conductors could also conduct enough lightning fire that, at the interruptions they might spark, which could lead to igniting a barn, a hayloft, and much more a powder magazine. This negative remedy of removing interrupted conductors is also much more necessary if one does not wish to practice the positive continuous conductors, since in such a case, the weather vanes, grates, chains, and iron keys serve no purpose other than to protect the parts of the building to which they are applied, and to conduct the strike more easily against the parts that are not adequately equipped. 300. To those who might doubt that, despite all these precautions, continuous conductors would induce some too dangerous familiarity and proximity of lightning to the given building, I will not object if they do not wish to take the further precaution of keeping it at a distance. 4 tall antennas erected at the 4 corners of a square building, and at a distance of several paces from these corners, and suitably armed with sharp points and continuous conductors, will conduct all the fire that could strike the building itself, and will carry it away, so that no reasonable damage need be feared from being too close. 340. But if someone insists that conductors attract lightning, and that from such an indefinite and poorly understood principle one could definitively infer, rather than the utility of the remedy, an increase in danger, I can only firmly respond that conductors do not attract lightning in any other way than by directing it to themselves and conducting it into their substance, that they do not attract any more lightning material by their force than that which they can conduct. That indeed they may sometimes conduct fire that would strike the building even without such conductors, but that they will always draw to themselves the majority of those lightning strikes that would hit it without them. IV. It is as vain to doubt that a suitably thick conductor continuously applied is the cause by which lightning is conducted to strike a building, as it would be vain to expect that letting a heavy body fall from the hand would cause it to rise. Just as gravity pushes bodies toward the center in a straight line, so the expansive force of electric fire determines it to move through the bodies that are most deferential or less resistant, which are certainly metallic. Finally, I do not intend to define the use of such conductors, but rather to propose, for the consideration of men, what observation and experience have persuaded me, so that each person may investigate this very important matter with their own observations and experiences, and then deliberate on it for themselves. And with such sentiment, O most esteemed Sir Beccaria, I shall conclude this letter, which has already become too lengthy, by expressing my admiration for your remarkable philosophical insights, which I have always found singularly impressive. P.S. 341. An electric spark revives mercury. A small amount of cinnabar enclosed in a glass tube, where it is traversed by the spark, appears darkened. I believe this results from the vapor that the spark excites from the sulfurous side. Meanwhile, in the darkened atmosphere, both with a lens and even with the naked eye, many small droplets of mercury can be observed. I have seen similar droplets revive, or better said, coalesce and become visible through similar sparks in many other mercurial contexts. A bit of zinc powder enclosed in a similar manner, when also traversed, emits from both ends of the tube 2 white wisps of vapor, which completely fog the interior of the tube itself, where I observe the flowers of zinc. In these effects, as in many others that I do not recall, before I have conducted large-scale experiments, the operation of electric fire, proceeding from an infinitely greater velocity, manifests the same effects as the operation of common fire. Chapter 15, Letter 15. On Achaea's meteors, 342. I am indeed troubled and fearful, most esteemed Sir Beccaria, whenever I consider the novelty and difficulty of the task to which I find myself compelled, to connect and explain the many apparently disparate phenomena of fiery and aqueous meteorology. Two things somewhat reassure me. First, the reflection that I am not solely driven by my own initiative to undertake such a difficult endeavor, but rather that I have been guided by observation and experience. And secondly, that thus far my work pleases you, most learned sir, who from your early youth have applied yourself with such attention and discernment to observe all meteorological appearances and to distinguish all their various characteristics, to whom I think I can trust more securely than to anyone else. These reflections invigorate and encourage me to proceed further in discussing the more gentle and tranquil meteors, just as I have done with the more impetuous ones, and to elaborate on that horrendous and flashing fire, which is itself governed by the most subtle laws of remarkably simple circulations, to the incredible benefit of plants, humans, animals, and every kind of tranquil cloud, and which brings, governs, and distributes in every manner the beneficial rains, purifies, enlivens, and renews the vital air. Proposition 27 Thigh. The rain-bearing cloudiness and its antecedent and concomitant phenomena, as well as the phenomena of storm, are produced by the same operation of electric fire, which from abundant places on the earth shoots into the atmosphere, dispersing through it the carrying vapors, and thus leads to places that are relatively lacking. There is only this difference: the phenomena of merely rain-bearing clouds are animated by a less impetuous circulation of electric fire, and proceed more slowly, more durably, and more broadly than the phenomena of storm clouds. 343. Besides the calm of the air, another incident precedes storms, which consists of many scattered clouds, appearing here and there in a certain order, especially over the mountains. They appear flat at their base and rise up into a kind of very mountainous and bumpy dome. These are then the active clouds that alternately approach distinct primary storm clouds. Now I observe that even rain-bearing cloudiness is preceded in spring and autumn by calm air and similar active clouds, which serve as their harbingers, but are less regularly flat at their base, less bumpy in their dome, and have less defined limits, proceeding for a longer time and moving more slowly. 344. And just as in the preceding incidents, so too in the act and manner of formation, the rain-bearing clouds proceed with a proportional similarity to the storm clouds. Thus I have often noted that the primary rain clouds, forming as if from a wide base and apparently contiguous to the horizon, are widely spreading towards the active clouds, and those in turn intermingle, merge, and soften their neighboring limits, forming a vast, united, uniform vaporous cloud. But there is always that difference that the rain clouds proceed with greater slowness and occupy a larger part of the sky, usually covering it entirely. 345. And similarly, the active clouds do not fail to cooperate with the rain-bearing clouds in the atmosphere, as well as other active clouds from the earth. Sometimes, before the rain-bearing clouds appear, a few active clouds can be seen in action, but the air, besides being sluggish, appears very vaporous. If it is daytime, the sky appears whitish, the sunlight is dim, the air is warmer or less cold than what the flagon carries. If it is nighttime, the sky is of a darker color, the stars shine less, appear more sparse, and their light flickers faintly. In such circumstances, it often happens that the sky uniformly becomes clouded in a short time and prepares for rain without any distinction of where the material composing the universal cloud originates. But certainly, the aforementioned circumstances make it clear that such cloudiness results from vapors that are initially very sparse and diffused in the air, and are successively drawn by the circulating and moving principle into the determined spaces, through which it can circulate among the various parts of the earth. Even when active clouds precede the rain-bearing cloudiness, The density of the resulting cloudiness does not seem to derive entirely from those clouds alone, nor from the primary rain clouds, but that the dispersed vapors, or we might say the active clouds in potency, also contribute to its formation. 346. But certainly, the active clouds from the earth also contribute to form and maintain such cloudiness. I think there is no one who does not observe that, as the season prepares for rain, many clouds are seen to emerge from the mountains, from valleys, and from rivers, and successively to rise towards the vast, uniform, universal primary cloud, in which they merge, according to which observation our peasants have a proverb, that as long as the rivers smoke, the clouds rain. 347. Not only do they draw the material for their vapors from such sources, but also in other incidents of motion, uniformity, and shape, these resemble them proportionally, motion with which the rain clouds, imitating the thunderstorms, form from a kind of dark cloud, and they swell in a certain way, drawing in turn the dispersed clouds. I have already said enough. I will consider here that common motion, where sometimes one sees the entire body of rain clouds circulating, just as the body of thunderstorms commonly does. Regarding this, I have often observed the rain clouds, without thunder or lightning, moving in a certain order, circulating from one nearby area to another, and making, as the sailors say of the winds, either the whole or a large part of the compass circle, just as the thunderclouds do more rapidly. And they excite other winds corresponding to their successive directions, complicated in various ways, depending on how complicated their multiplicity and the direction of each one. It is 548. I have similarly said enough about the total shape, particularly about the limits of the primary rain clouds and of the uniform, broad, unified cloud, which they finally compose and join with the lightning. But the accidental phenomena that alter such shape and uniformity in the thunderclouds must also alter it in the rain clouds. Thus, even in the broadest branches of the rain clouds, I have seen round prominences hanging toward the ground. I have also frequently observed many strands of cloud, parallel and descending, toward the ground from the ends of those branches, and those strands fading and disappearing successively in their lower part, so that they do not reach the ground. 349. And finally, the clearing of the clouds is not different in the rain clouds than in the thunder clouds. That is, at the end of the rain, the sky appears covered by a thin, uniform, hazy cloud. Beneath it, various clouds appear, very much and uniformly hazy at their limits, and over their entire surface. The veil of the high, thin, uniform cloud becomes more and more sparse and white, and it allows the light of the sun, poorly defined, hazy, dim, and squalid, to penetrate. As the thinning of the clouds progresses gradually, the light of the sun becomes more vivid each hour, and finally the sky appears joyfully serene and clearer and more radiant than usual. 350 now. Regarding the proportion of the formation of the various accidents and of the clearing of the merely rain clouds and the storm clouds, it would certainly suffice by itself to moderate the same half of the operating principle, and to conclude that, since such effects do not vary except in size, there is no other variety of cause than in understanding. But certainly I will not stop at such an analogy of effects when I have immediate observations and indeed experiences that the very cause immediately manifests to me. 351. And to begin with the observations, I will first present one that seems suitable to reduce to the same principle of the thunderstorms. Not just the rain clouds, but also the snowy cloud formations, and that many times on completely dark nights, sometimes in winter. I have observed clouds scattered across the sky merging into a universal cloud, united, uniform, apparently not very dense, and spreading everywhere a reddish light that is indeed uncertain, but enough that I could read books of medium print. I have commonly observed such nocturnal cloudy brightness on snowy nights, unfortunately when the snow was falling. Also, this past winter I observed such brightness with some of those religious gentlemen of the mission, and now I find that, as for the appearance, it is indeed described in the Anglican Transactions. And regarding the cause, I think this brightness comes from electric fire, to which universally belongs the formation of such universal united cloud formations. And circulating in a slightly greater quantity than what can be transmitted through the pores. It must shine, as many domestic experiences show. And the very small and frequent flashes of light corresponding to the interruptions of the less dense vapors must degenerate into a broad and uncertain brightness. I am confirmed in this thought, considering that often, even during the day, I have seen some less dense parts of the thunderclouds, which otherwise appeared animated by their circulating force, spreading a similar brightness independently of the sunlight. 352. But that observation does not otherwise prove the operation of electric fire in the rain and snowy cloud formations, except in that it finds in it a convenient explanation. Another is suggested to me by Mr. Dr. Kaburi, which, if universally confirmed, proves the said operation immediately and evidently. The aforementioned professor, on the occasion of his stay in Canavis in 1754, gathered that in Orio Mr. Abbot of St. Albino and many attentive old men observed that when they saw flashes to the north of Orio in cold weather, it usually rained in Orio within 2 days. This October in Genoa, 2 ship captains assured me that indeed the wide and frequent flashes which spread at night across some part of the horizon laden with vapors bring clouds and rain, even if they do not stir up high winds. Now certainly that connection of preceding flashes and the consequent cloud formation, since we know from thunderstorms that the flashing fire aims to operate, clearly shows the connection of cause and effect, that is to say. It is clearly seen that sometimes the fire producing the clouds begins to sparkle through the rare vapors, and thus successively gathers others and arranges them in the clouds, from which the cloud formation results. 353. Although to what extent I draw conjectures from the nocturnal cloudy brightness, or from the flashes heralding the cloud formation, when indeed anyone can commonly observe the flashes tending to excite, promote, and animate in all their motions and accidents certain merely rain clouds. Even in those around mid-December I observed a kind of rain cloud that unfolded from the north with many frequent flashes, and as if animated by them, it spread a very broad branch over Torino and brought rain for several hours, although no rumbling of thunder was felt. From this kind of observations, it is known how the electric fire operates in various ways, guiding all the different degrees of its force. It is the same fire that thunders horrendously in the ruinous thunderstorms and excites in silence the gentler cloud formations. 354. To demonstrate even more evidently that universality of functions of such an operative element, I will finally present the observation, which I wish to call the ring of meteors, which indeed serves me as a ring to connect with the fiery thundering. To connect with the fiery thundering and lightning meteors, the most pleasant aqueous meteors. That observation consists as follows. Frequently in the summer, in autumn, and in spring, one sees for many hours or even for entire days the sky scattered with little clouds of, when finally one perceives some broad branch slowly unfolding, as if from a large and very dark cloud. In such a state of affairs, sometimes suddenly, a thunderclap is heard from the aforementioned branch. And behold how instantly the face of the sky changes. The slow branch already runs, already intertwines with the nearby little clouds, already forms with them a solid body. And this mutual union and uniformity progresses beyond the more distant little clouds. A single cloud covers the entire sky, producing a gentle rain and sometimes very lasting, without any other thunder or lightning being attempted. In the autumn of the previous year, while I was on the Garzegna Hills near Mondovi, I have often seen such a cloud formation expand as if in response to some distant thunder, which others could hardly distinguish. In the last spring and in the previous summer, I have observed such a thunderous play, where a universal cloud formation rapidly progressed, followed by the most tranquil rains, in which series of events it seems that nature itself wishes to communicate with us through thunder, whatever the actual instrument it employs to produce all the subsequent effects. Therefore, although one may no longer see or hear the operator of the electric fire, one should not conclude that it does not continue to influence the subsequent phenomena. Thunder is the effect of a resistance that is broken by a surge of accumulated electric fire, signifying its ability to break through. Once this resistance is overcome, a path is formed, and the fire begins to circulate through it almost uniformly and continuously. The gross organs of our senses cannot perceive the restless element except in your strongest operations, because it naturally seeks to penetrate and operate within bodies and to maintain itself therein. What then does experience show? It is that it has familiarized us with the lightning and the previously unmanageable fire, and it has revealed to us its astonishing properties, and this is what allows us to perceive and observe it, even in many of its hidden functions. When and where no man had ever previously recognized it, thus, in the case of the previous observation, a single thunder was perceived, and at the very moment when the universal cloud formation accelerates correspondingly. My conducting wires do not fail to sparkle with great intensity, and although the other incidents of the cloud formation proceed in silence, the aforementioned wires do not cease to sparkle more or less strongly, or to give other signals proportionate to the nature of those very incidents. This should certainly persuade everyone that it is the very fire that excites, leads, and governs all the subsequent functions, both of the thunderstorms and of the purely rainy clouds, and consequently it is necessary to proportionately adapt the explanations I have provided regarding them in other letters. And thus, I wish to conclude that even the purely rainy clouds are excited, formed, united, thickened, or dispersed by the terrestrial electric fire, which from the places where it abounds strikes into the atmosphere. And therein it often expands the conducting vapors, and through it broadly distributes and arranges them, and draws others already diffused in the atmosphere into its path, and excites others from the ground, also unified, thickened, and ordered, that they can easily spread equally towards those terrestrial places which respectively reflect them. All the difference between the thunderclouds and the purely rainy clouds will depend on the different strength of the motivating fire. In the thunderclouds it pours down in torrents, and thus thunders, flashes, strikes, and fulminates, creating, moving, and dispersing the entire cloud mass with particular rapidity. But in the rainy clouds it proceeds gently in lesser quantity, and with lesser density expands more broadly, perseveres more in its circulation, and thus completes all its functions in silence and tranquility. To represent in miniature with artificial electricity the gradual formation and the precise limits, and the curvature, the uniformity, and the dispersion of rainy clouds, I hope that those who can rekindle in a small spark represented, as in miniature, an image of lightning will also be able to discern in the incidence of a tiny electric cloud those that in natural clouds are produced in large quantities by the overflowing, unbalanced terrestrial electric fire. Therefore, I attach a spoon to the chain not far from the globe, and place some well-heated coals in it. Then I carefully isolate it, communicating neither with the chain nor with the machine. And with the cloth I rub the globe, and with the desire I spread the powdered colophony over the heated coals. The smoke that arises from the colophony directs itself towards my hand, wraps around it, and continues to progress along my arm, spreading around my shoulder, enveloping my back and investing my forearm, thus surrounding a large part of my body, and encircling it with a true cloud, which can form a barrier to the electric fire, so that from the chain through my desired arm, through my back, and through the forearm it circulates to the globe. In that experiment I take care to wrap my desired hand with some cloth bandages of many layers, and in addition to wear a coat that is entirely suitable for the purpose, both to protect my hand and my garment from the colophony which sticks and smudges, and also because I have experienced that the smoky cloud proceeds more slowly and spreads more broadly around my body, forming around it a higher smoky cloud in proportion to how much I am covered with more cloth. By operating with such precautions, I rekindle in that artificial electric cloud many very admirable things that operate in the natural electric fire, which abundantly circulates from the chain through the spoon and then through the smoke. Certainly it is this that directs the smoke around my hand, around my arm, and around the various parts of my body, which through the continuous rubbing of the globe begin to reflect it, just as the terrestrial electric fire does, resting electric fire in the atmosphere, and it causes the different vapors to rise and bend towards the places that respectively reflect them. 361. The uniformity and the unity of that cloud so effectively represent to me the uniformity and the other propelling and distinguishing characteristics of natural rain clouds, that such representation alone would convince me of all that I have attributed to the action of electric fire regarding the formation, growth, progression, and other such accidents of natural clouds, where that artificial cloud distributes itself with a continuous union, parallel to my garments, and as its height appears, it seems composed of continuously and gradually thicker layers, all parallel to my garments. And in the form of its entire continuous interior and orderly texture, it shows that admirable uniformity which I have constantly contemplated in the high uniform, broad, universal, and finely shaded cloud. 362. And I observe no less conformity in the limits of that artificial cloud, and in their progression, which, just as the primary storm clouds, and also the rain clouds advance and expand their limits, while still maintaining their curved united and terminated forms, so that artificial cloud successfully advances its upper edge, and like curved waves, united and finally terminating, it continuously promotes itself further, bending over the additional parts of my body. 363. And finally, that playful image also vividly represents to me the dispersal of rain clouds, since sometimes, after observing the phenomena mentioned thus far, I take pleasure in lowering my head and bringing it close to the chain, and behold, a lovely cloud disperses and flattens, and then immediately dissolves, rolling away as soon as I touch the chain itself. And the vapor that follows from the spoon no longer directs itself to my hand, but rises up, and in the chamber it loses its natural form. From this I see that just as the circulation of the terrestrial electric fire languishes and fails, the different clouds disperse and vanish, and are pushed away just as the residual vapors are also electrically dispersed, and are widely and uniformly scattered in the atmosphere. 364. Observing all these things carefully, I clearly and truly distinguish in that artificial little cloud the clouds of nature, just as today all philosophers distinguish lightning and a spark, so that it is fitting to say that the electric fire, which is the cause of the rain cloud formation, also influences the rain itself, in which inquiry you can see well learned Sir Beccaria, that I would need to recount infinite things, rather than merely adhering to the truth. I would be idle and foolish to wander through the opinions of men, for others claim that rains are nothing but vapors condensed by cold. Others prefer to think that clouds and rains are vapors, more or less condensed by two winds that collide head-on. Others, on the contrary, want to believe that in that region rain forms from which two winds depart towards opposite shores, that in such a region, they say, the very district will become lighter. They support this fact with observations of Mercury, which rises in rainy weather, and will not hold the vapors that fall from above, and in falling will condense them and form the rain. And finally, others fabricate various opinions at their leisure, of which I do not know if there is a number, or if it matters. And to those such varied opinions, behold, most worthy Sir Beccaria, what simple confirmations I dare to oppose, drawn from observation and experience. The same electric fire which excites and governs the rain clouds is also active in causing them to turn into rain with all the ordered phenomena that immediately precede the rains and are necessary for them. 365. This electric fire, which dissipates in the surrounding air the small particles scattered over the chain, suspends and unites them into many clumps, and in long strands the crust, the fluff, the hairs that appear on a plate presented to the chain. The same electric fire, which divides and scatters into indistinguishable droplets, a very fine sprinkle of water, which I cause to spout from the chain, unites and joins the droplets of electric vapor with the droplets of a similar very fine sprinkle, which I cause to spout from the machine. Therefore, the electric fire, which lifts and spreads the terrestrial vapors in the atmosphere, and moreover, gathers them into clouds and arranges them just in the space of its propagation, will itself be active in further condensing them and turning them back into water. 366. Nor is this all. I also observe in the electric fire a peculiar aptitude to gather the vapors to form rain, with all the particular accidents that pertain to such a natural phenomenon. as I have already extensively exposed in the previous proposition, that the rain cloud on the verge of producing rain particularly unites into a single uniform body, and with the small artificial electric cloud. I have indicated that indeed a continuous current of its electric nature is apt to produce such an astonishing accident, when it is compelled to spread through the resisting air and must form itself into a conductor through the different bodies. And the uniformity, the union, and the order of the artificial cloud so vividly and similarly represent to me the uniformity, the union, and the order of the natural cloud about to dissolve into rain that I cannot imagine, if it does not manifestly cause such similar effects, and just as in that artificial cloud, so in that natural cloud, I cannot distinguish any other efficient principle than the orderly and active operation of the electric fire, which subsequently and orderly proceeds, and with the vapors correspondingly constitutes a continuous and orderly little bubble. 367. And no less clearly do I then see the operation of the same principle in the other, accompanying and successive accidents. I will here briefly and clearly expose those, and in the end I will explain how active the operator is in producing them all, the meteorological element in a certain way. 368. Therefore, first of all, I observe that at the time of the approaching rain, not only does the cloud acquire a particular union and uniformity in its entire broad body, and in each single part, but moreover it also tends at that time to lower itself very significantly, and uniformly and orderly to spread its lower broad, most united face towards the ground. And it is then that the rain, if the cloud is sufficiently thick, opaque, does not delay in falling. 369. But then in the actual rain, I observe another very regular accident, which is no less worthy of being noted, and is no less fitting to my proposition. And it is, to express it briefly, the uniformity observed in every rain, and the infinite variety of different rains. In each singular rain, the commonality of the drops has a similar size. The drops that fall in the same shower have similar intervals, the frequency of successive drops is similar, and that order in gentle rains changes only gradually, while it changes more rapidly in heavier rains. 370. That rule, so obvious to the eyes of all, seems to me to be so admirable and commonly neglected, and not diligently noted. It truly leads us to see a similar rule in the position of the vapors that unite, and in the intervals of the centers where they unite, and in the quantity of those that unite around each center, and moreover it shows us that the cause of the union progresses with a similar rule from one vapor to another. 371. And thus, having established an order of vapors, of their union, of the centers of union, I contemplate not only the order of the rains, which is like the effect of that, but I also see and observe in certain opportune circumstances. Many times, giving myself to observe these delicate moments, and in the most opportune position, I notice a very fine drizzle that emerges from a wide, dewy, and very fine cloud, or rather mist. First, I take pleasure in observing how the parts of it are distributed with an admirable continuity and uniformity, so that the air is equally filled everywhere, and that with a very orderly progression, it is more densely filled at greater distances from the ground. Secondly, nothing less captures my wonder and attention than the orderly motion, by which other parts of such mist alternately combine into tiny drops or shining minute beads. Indeed, the minuteness of such parts and the multiplicity of their movements do not allow the motion of each to be distinguished from the motion of each other. Yet all this does not prevent countless particles from vibrating uniformly, shining similarly in small segments coming together, and thus forming the most ingenious drizzle, the drops of which I then observe distributed on my clothes, equal in size, similar in small intervals, and entirely 372. And those are the most orderly occurrences that I often bring all together before my mind, and I strive to relate them as effects to their causes which the philosophers have assigned to the rains, but in vain. For I find no proportion and no connection between them and those. It varies whether it is disturbed by the winds or pressed by them, and thus either allows the vapors to fall without sufficiently supporting them, or presses them in some way. Nothing presents itself to my spirit but tumult and disorder. The winds that blow from opposite sides against the place of the cloud will crowd everything into the center of their action, and there, instead of dispersing it widely and orderly, they will compress it into a tight, dense mass, or rather a torrent. The winds that blow from the place of the cloud in opposite directions, why do they not disperse it, since their opposing directions affect different parts of the cloud? Or if they allow it to fall due to the rarefaction they induce in the air, why do they not all compress it together in one blow? For if the rarefied air no longer supports one part of a cloud, I do not see how it can support another remaining part, which, on the other hand, appears equally dense and equally heavy. 373. I omit that it rains very frequently without any very perceptible wind, that the winds, however violent, such as those that would have to either accumulate or disperse a significant part of the air, more often distort the rain when it is imminent, as I have noted happening in thunderstorms. I also omit that the mercury in barometers tends to oscillate quite regularly when the season is approaching rain. However, usually at the beginning of the rain, it does not lower further, but often begins to rise, and not infrequently very lasting rains occur, keeping the mercury at a height greater than the average. All these observations clearly indicate that the wind, although sometimes they are an instrumental cause that supplies the material of the vapors, are never, however, the formal and efficient cause of the rains. I focus solely on the comparison of the action of the winds with the occurrences related to the rain, and in that only comparison, I find such disproportionality that certainly has no place between any cause and its proper effects. 374. But on the contrary, as soon as I turn my mind to consider the natural constancy of the electric fire, which always seeks to spread widely and uniformly among the parts of the resisting medium, which is the air, and to conduct and distribute among those parts the different particles with order and corresponding uniformity, I then revive how an orderly current of this fire must present everywhere uniformity, order, and union in all the vastness of the innumerable particles animated by it, as well as in all the successive alterations of the same. 375. Let us suppose, shortly we will see that the hypothesis is in accordance with the truth, that the rain begins to form at the moment it starts to descend between the clouds and the earth, a particular uniform, continuous current of electric fire. And I will proceed as if such a current will by itself be sufficient to produce all the various orderly occurrences. 376. First, it is a manifest principle of experience that the electric fire, which flows from one to another term that is unequally electric, carries with it a much greater quantity of particles the more it flows in greater quantity, if it does not reach to flow scintillating, in which case it rejects the air, which is the resisting medium. Thus, it does not need other conducting particles. Now, from that principle it follows, as a necessary consequence, that a particular and more copious current of electric fire must begin to flow between the earth and the clouds. And along the path of the same, it must procure for them a proportionately more conducting medium. It must lead along its path other and other vapors, and it must bring them closer together, and thus particularly condense them. The darker clouds, which are generally the densest and most gloomy, confirm the truth of such a consequence. Thus, here is how the particular current that begins to form the rain must cause the clouds to particularly condense, and so thicken, and also to lower towards the ground, following the direction and strength of the same current. 377. Secondly, it is equally established by experience that the particles that conduct a current between two unequally electric terms are held proportionately farther away from the term to which they can give, or from which they can receive. More easily, whatever the reason for that greater ease, the electric fire. Thus, for example, a metallic leaf balances between the chain and a foreign body at distances that are inversely proportional to the ease with which the electric fire transfers from the chain to the small body, and the ease with which the same fire transfers from the small body to the foreign body. This is demonstrated by attempting to provide various degrees of ease in conducting to the leaf, which ends in points that are more or less acute, equal or unequal, or by attempting to provide different degrees of giving and receiving to the chain and the foreign body, or by altering in some appropriate part the shape, or even by changing the material. From this principle, it follows that in our case, the particular current must indeed tend to condense, and particularly the cloud nearby, to precipitate into rain. But it must not, therefore, either unite with the ground or condense it uniformly according to its height. Rather, it must orderly diffuse towards the ground from its lower face. For I prove that the bodies that are on the surface of the earth are indeed more deferential than vapors. Hence, if the upper part of the cloud is considered as an unevenly electric term, and the earth as another term, between which the particular current of fire indeed transfers, the entire part of the cloud that reiterates in the middle will unite more to the upper part than to the earth, as that is less different from the other. And applying the same reasoning to each vapor which I am bringing forth for the part of the cloud that reiterates in the middle, it will result that the vapors closer to the ground will distribute themselves at gradually greater distances, and those farther from the ground will distribute themselves at gradually smaller intervals. Hence one will see them spreading from the highest part of the cloud, condensing particularly like an orderly and progressively rarer vapor. 378. And in the third place, the same principle that will regulate such a distribution must certainly also form and order the rain. In proportion as the current of electric fire has conducted a greater quantity of vapors into its vicinity, it will condense them more. And when the quantity of vapors is sufficiently abundant for this purpose, in the place of the minimum intervals, for the law of distribution will always remain the same, it will come to condense them maximally, to vibrate them till contact, to unite them into tiny droplets. And indeed it will arrive at reuniting those tiny droplets among themselves into larger ones, and those into others, and into others progressively larger, which will finally fall through a series of smaller droplets and other vapors, drawing to them a large quantity, and thus enlarging proportionately both to the quantity of the current and to the density of the cloud. And that progression of the union of vapors and of droplets and of their fall, and of their progressive enlargement, will proceed orderly, continuing through the current of electric fire, which, due to its uniform continuation, will proceed with fervor along a uniform and continuous conductor, and thus will continue at equal intervals of space and time other vapors to vapors, which will become united in the first-order droplets, etc., and other droplets falling to those that will have fallen in the previous moment, and thus the rains will be brought forth, and will continue with all the admirable order that we have divided in them. Proposition tertii X. The particular current of electric fire, which tends to manifest itself in deferential threads a short time before the rain falls, and to terminate a short time before the rain either ends or ceases, proves how it truly is. As a determined operation of the circulating electric fire which forms the rains, that sometimes certain rains occur without the particular current manifesting itself in the deferential threads, that sometimes the sky is covered with a cloud so united, without the deferential threads giving signs of such electricity, does not prove that such rains and such clouds are not produced by the operation of electric fire. 379. The electric fire, which I have thus far shown to exist in the raining clouds, and to be capable of transforming them into rain, evidently then manifests itself as the author of that, with its most significant correspondence and proportionality, which further relates to that very cause concerning its effect. For from my observations it first appears that, a short time before the rain falls, particular sparks begin to appear in my deferential threads, just as it is the effect of a cause that begins to operate in the subject, and takes some time to dispose it to the effect. It appears, secondly, that the particular sparks accompany the rain, in which again the character of the cause appears, which continues to operate durably to maintain the effect alive. Thirdly, it appears to me that the particular sparks finish a short time before the rain ends, and this is also a character of an effect, which, having been produced by the cause, indeed lasts for some time longer, since due to the force of inertia it must occur in every alteration, but finally it indeed ceases and is absent. My observations show me, fourthly, that the particular sparks, which are indeed forerunners and companions of the rain, correspond also in intensity, that is to say, in strength and frequency. Thus, when it drizzles, the sparks are smaller and intermittent. When it rains, they are lively and continuous. And when the rain falls heavily, the sparks are sharp and thunderous, and they spontaneously and strongly leap forth, and then they are preceded by flashes, to each of which, as everyone knows, correspond indeed heavier downpours. And such a correspondence, which appears so manifestly between the rains and the particular proportional currents of electric fire, is what, as I see it, provides evident support to the argument presented, and of the certain existence, and of the singular aptitude, which those currents have to produce the rains, and makes me bold to conclude frankly that they are the efficient principle that forms, attains, and produces the rains. 380. Therefore, in every instance of rain, there is always a particular current of electric fire. However, even if it always exists, it does not always need to manifest. And I have often observed that I see it always. 381. For three main reasons, a particular current of electric fire must be able to form the rain and be able to escape our observation, due to its tenuity, due to its direction, and due to our imperfection in exploring it. The proportionality that must appear between the currents and the rains, as between cause and effects, leads me to see that at the finest raindrops must correspond to very faint currents, and just as the droplets of those are barely discernible, so too must the particular particles of those be easily distinguishable. From this, I think it is partly due to the fact that in such raindrops I have observed the corresponding particular scintillations 3 times. I blame myself. Even when the droplets were indeed very minute, and they vibrated with some particular speed. 382. However, it should also be noted that such currents which form the small raindrops must not only be very tenuous in themselves, but must also be incredibly more so, compared to our observation. For in such raindrops, the rain vapors continue down to the ground, and the very frequent droplets, along with the great humidity, which the air absorbs particularly and specifically, form, as it were, a wide and continuous conductor that is very deferential, through which the majority of the smallest currents must necessarily pass. Thus, their residual part, which should produce either an effect or a defect perceptible in the conducting wires, will be minimal. Hence, in such circumstances, I have considered the slight movements of the flax fibers as demonstrative signs of particular currents, which movements are usually not absent even in the very minute raindrops, and often have been particularly lively. 383. And for the same reasons, I think it happens that even in the following rains, which are continuous, the scintillations tend to become very rare, or even to completely cease for entire hours, that is, when the rain falls smaller and more sparse, for the preceding heavier rains must have thoroughly saturated the air with moisture, so that it conducts almost entirely the continuous ordered and slow current, and the subsequent rain almost entirely carries the residual part. In fact, the very orderly rule with which the scintillations in such rains both interrupt and restart not only confirms my thoughts, but also marvelously supports the entire present theory, from which the correspondence of the electrical currents with the rain suggests that they are the efficient causes of those. For the scintillations weaken or cease in proportion as the force of the rain weakens, and each time the rain strengthens, the scintillations return proportionally lively and frequent. Thus, I see from my records that on a single afternoon, several times the scintillations weakened and ceased correspondingly to a rain that continued all day, and just as many times they revived correspondingly to its strengthening. 384. However, in addition to the fact that the electrical rain current may escape our observation due to its respective faintness, it may also not manifest itself to anyone because it does not direct itself towards the place where we observe. The part of the cloud that covers us may act as a simple conductor between other adjacent parts, which otherwise receive the electric fire from the ground and return it elsewhere to the ground, without giving anything to the place of observation, nor receiving anything from it. For this reason, I attributed a certain irregularity that I observed on the 31st of August, a very long cloud coming from the eastern hill as soon as it reached above my observatory, excited in my conducting wires signs of electricity. Shortly after, when that cloud had advanced significantly towards many crowded clouds on the western mountains, and was already joining them, it rained for a few minutes, and in the meantime the scintillation ceased, When it united with them into a single body, the rain continued, and the signs of electricity reappeared due to the defect. Now that cloud, upon approaching and uniting with the clouds of the west, appeared to me as if it were a web of horizontal straight threads, parallel and stretched from east to west, which appearance signified to me the direction of its circulating current, which, having found a nearby and ample outlet in the clouds of the west, must have spread solely in them, and in such abundance that finally the cloud refused the defect of fire with respect to my observatory. 385. Finally, we can and must often add the electrical rain currents, especially when they are not very copious, due to our imperfect manner of exploring them, in which I certainly could not apply as much diligence as I would have desired, for I could neither ensure a sufficient effectiveness of the insulation, nor could I practice, except for a few days, a conductor wire that was very long. And finally, I had to observe in a place that was not very high, nor entirely free. In truth, for the effectiveness of the insulation, I practiced on the wire of the pyramid a glass bell covered by a small umbrella, and a cord of silk that remained humble under cover. But in humid and rainy weather, both the glass and the cords must not contract the humidity of the atmosphere, and such humidity of the insulated bodies must not maintain a balance with the electric fire of the ground, and the electric fire of the conducting wires, thus rendering them inept to signify the faint currents that flow between the ground and the clouds. Therefore, in humid and rainy times, I changed the cords on the conducting wire of the attic, and immediately the signs revived. But often the humidity rendered the remedy useless. A double fire holder should be attached to each of the cords, maintaining some glowing coals. Such is the remedy with which I primarily conduct experiments of artificial electricity, even in the most humid season. I hang a double fire holder on each of the cords that must insulate the chain. I apply a curved fire holder in a circle around each of the glass feet that must insulate the machine. I keep a small fire holder under the glass globe, etc. And in this way, many irregular deficiencies of the signs would be remedied. 386. And since the conducting wire carries stronger signs in proportion to its greater lengths, it would also be desirable to practice, as much as possible, a very long one, in order to obtain signs even in the falls of minimal currents. In truth, I would have wished to continue my observations with the very long wire of my filament, but the difficulty of preserving it and reintroducing it was not small, and I willingly avoided any shadow of danger that could have brought me into storms. 387. Finally, the place not being very high and free may be the reason that many times the currents still sink even when they are very strong. A very long wire stretched between the summits of two very tall towers, in a place not dominated by buildings or other higher eminences, would universally have brought me the signs more readily, as I have proven elsewhere, and more frequently, and would have demonstrated my named currents more significantly than due to the nearby eminences. Z, as were the pyramids, and the hill of Levante, must have largely dissipated. 308. Considering on one hand the least effective manner in which I have been able to experiment, and on the other hand reviewing and examining the series of my observations, I find that their form corresponds very accurately to the theory from which I have derived it, and that the irregularities of those forms correspond precisely to the imperfect manner of experimentation. 309. Nor should I fail to point out that all the causes mentioned, much more than the electric rain currents, must also affect the more subtle, sluggish, and rarer currents, which the slow-moving clouds carry very weakly, and which they gradually disperse into rain. This is the most magnificent nature's disposition. The very active principle it employs guides all possible measures to produce a complete series of infinitely varied effects in intensity. And the limited senses can indeed discern the operating principle in all the parts where it is expressed in sufficient quantity to cause them a commotion strong enough. But where the principle operates in a lesser quantity than such need, the senses want to be affected by reason in order to recognize in the constancy of the effects the constancy of the cause. Proposition 21I. The sudden freezing of hail is largely contributed to by the cold, which dominates much more intensely in the air at a higher altitude, and perhaps some other causes must also contribute to the same effect. namely the very rapid movements of hail clouds. The growth and fruiting of hail evidently proceed from the violence of the electricity dominating in the hail clouds, whereby copious vapors gather around a certain center, and from the unequal source of dominating electricity in the successive layers of hail clouds, such that when the first nucleus falls, it attracts around itself others, and other successive layers of copious vapors, and partly due to their own cold, partly due to the further cold that this nucleus communicates, it converts them into ice immediately. 309. That hail forms at a particular height in the atmosphere is clearly indicated by one of the signs that farmers use to predict it. For they are most horrified when they hear a very loud thunder above their heads, and two other signs, from which they predict the imminent hail, are the color of the cloud, which is completely dark and gloomy, and certainly a rumbling, which is felt thickening the face of the cloud, exposing the cause of why the cloud is driven to thunder at such a high altitude. For the thickness of the cloud is proportional to the current of circulating fire, and the rumbling in the cloud is nothing but the strong and continuous vibration that it excites in the surrounding air abundantly. Now it is indeed very consistent with the nature of its electrical director of the clouds to elevate them higher in proportion to its greater quantity, and to bend them into a higher part of the atmosphere due to the rarer and less resistant air, and thus in such a high place to circulate and thunder. 391. The impact of hail confirms those conjectures. In number 203 of the Transactions of the Royal Society, it is stated that hail in Lee broke trees and knocked some down. In number 229 of the same, it is reported that a hailstorm in Yorkshire buried some people. The force of the fall showed that it had fallen from a great height. In the same number, it is said that a hailstone had made deep holes of 1 inch and 1.5 inches. Some large hailstones fell so violently into a well that they caused the water to rise to a height of 1.5 yards. Some hailstones bounced from the ground to a height of 2 yards. In the same number, it is recounted that a hailstorm in Herefordshire split the ground and broke many trees. Every year, some region of our country provides such examples of the effects of hail, thus proving that it forms at a particular height above the ground, 392, but at a certain very high altitude. A colder temperature dominates than that which is necessary to freeze, as is indicated by the adhering snows of the mountains. And such cold at a certain level must also be more intense over the plains than over the mountains. For the part of the same stratum of the atmosphere that covers a wide and open plain is certainly less dominated by reflected light and by the terrestrial temperature. Thus, whenever the force of the electric temporal current rises sufficiently to elevate the clouds to such an appropriate height, and at such a height it condenses to form rain, it will immediately harden into grains of ice due to the dominating cold there. 393. And just as the electric current abundantly procures the freezing of hail by elevating the clouds to an extraordinary height, it must also procure a particular thickness to each grain by gathering in each one a strange quantity of vapors. For just as we have seen that the electric rain current brings raps proportionally to its strength, larger and denser, so the electric hail current, allow me to combine some words to spare myself many, will violently gather a greater quantity of vapors in each of the centers of unequal electricity, and thus will form the nuclei of hail to be so large. 394. I say the nuclei because the distinct it's the different varieties of ice that make up the grain of hail, are formed successively while the nucleus is falling. For how could we ever think that a grain of hail, some of which, as the Transactions of the Royal Society indicate, sometimes reach 10 and even 12 pounds, is formed in an instant, in a single point of space and time? Moreover, when breaking a grain of hail, everyone observes that it is gradually more opaque and wider towards its center, and the successive layers of it are more transparent. And those transparent layers return to water more readily than the nucleus, which further indicates that the parts closest to the center must form due to a colder temperature, and therefore at a proportionately greater height. And finally, It is such that it is necessary that when hail falls from a great height, it draws a large quantity of vapors from the successive higher strata, which, if one considers their successive greater proximity to the ground, one sees that they must have a successive gradation of unequal electricity. And therefore the falling nucleus from the higher strata will encounter in each successive stratum a degree of unequal electricity, and while in some parts it will balance its electricity with that of others, drawing around it other vapors. And thus it will successively and gradually increase its volume due to the great space of its fall, since the vapors that it successively collects, partly due to their own coldness, and partly due to the cold they encounter in the core, exceeding the freezing point, will also freeze. 395. Although this most natural manner of the successive enlargement of hail seems to require no further confirmation, I will not omit a very pertinent observation made by Schucher, Vermond, and Muschenbroek, which is also very common among our mountain dwellers, and that is that in the highest mountains, hail usually falls smaller. This likely occurs because the clouds above them rise proportionally less and do not double as much. Hence, the falling grain must encounter and draw a smaller quantity of vapors, and thus receive less increase. And here is how, most distinguished, sir, from the theory of electricity and from natural observation, the explanation of hail arises. That is to say, one of the most astonishing and still less understood phenomena of nature. However, just as nature, the provident operator, connects everything with everything else in an infinitely ample manner, and tends to influence the fullness of the same effect with different partial causes. From this, I doubt that even by another means it could cooperate in part with the freezing of hail. Indeed, although all storm clouds move with astonishing rapidity, the movement with which the lower and secondary clouds agitate themselves is exceedingly rapid, especially at the moment when hail is imminent. Elsewhere I have described this phenomenon. Here I will take the opportunity that presents itself to explain it briefly. Such low, ragged, shapeless clouds, agitated in their motion, unstable in their form, are certainly like intermediaries between the higher, hail-producing clouds and the earth, similarly to how a metallic leaf moves between the plate and the chain along the same chain, and is effectively conducted to other places, where it encounters new and more copious currents. Thus, if you allow me to express the most magnificent effects of nature with the smallest tricks of art, these clouds are violently dragged by others to other places, where the electric hail current flows with greater force, and in this way they change both in position and in shape with such rapidity and such boldness that only through observation can it be comprehended. But as for the point that pertains to the formation and freezing of hail, of which those Uranian movements are certainly signs, would they not also constitute a partial cause? The water, which in a glass filled with rarefied air freezes dramatically when it is still, but as soon as it is agitated, freezes in an instant. The water rotated in certain clay vessels cools, as Mr. Demeron narrates. Art does not promote freezing sufficiently except through a certain motion. Would it not then be probable that nature also employs the same means for the same effect? Indeed, since in hail we see combined both the effect of freezing and the means of a very rapid movement, should not that influence the freezing due to its attitude and its adaptation? Therefore, I suspect that through such violent motions, the vapors are brought to a greater cold than would be suitable for them if they were left still, and thus they are also found to be more disposed to freeze around the falling grain. Proposition 22 a tranquil and orderly circulation of electric fire is that which forms snowy clouds, 2c. This circulating electric fire is such that it has brought the vapors close together and vibrates them against each other. As we have seen, they must come close and vibrate to form the drops of rain. It will form if it dominates in a freezing cold the flakes of snow. 3. And such an operation of electric fire is singularly active in producing the admirable effects of snow. 397. I will not dwell much on proving the first two parts of that proposition, since it is evident that snowy clouds do not differ from rainy ones, and snow does not differ from rain, except for the particular accident of cold, Thus we see that the same clouds, which here in Turin form snow, usually dissolve into rain beyond the city of the Maritime Alps, 398. If, besides the accidental particular cold, there is any other difference between snowy clouds and rainy ones, it reduces to a lesser intensity of the same operating principle. Therefore, the union, the uniformity, the orderly distribution, both throughout the whole body and in each part of the universal snowy cloud, the lower face of which is uniformly directed towards the earth. And in a word, all the characteristics that reveal the operation of electric fire in rainy clouds are particularly evident in snowy clouds, 399. And if we consider the particular alteration proceeding from the particular accident of cold, the characteristics that represent the operation of electric fire in rain are no less conforming to the characteristics that present themselves for consideration in snow. Thus, in every snow, it is admired that the falling flakes maintain a certain orderly arrangement, both in the intervals of the places where the flakes fall at the same time, and in the intervals of time with which other flakes succeed one another, and in every snow. The commonality of the flakes exhibits a particular size, a particular shape, and a particular figure. And in different snows, an incomprehensible but always orderly variety is observed in all the aforementioned accidents, 400. All these things, just as they signify that the same cause produces both rain and snow, so they do not fail, just as in rain, to immediately manifest to us that same cause even in snow. I have already expressed elsewhere how the flashes that I have frequently observed during snowfall have always brought me a vivid sign of electricity, strongly vibrating towards my finger, the hairs attached to the regulating thread, and sometimes even pricking my finger with a small spark. And this year the conducting wire of the pyramid, the wire of the attic, is broken, and I could not replace it during the snowfall, and while it is currently snow, vibrates so strongly towards my finger, the hairs attached, and so continuously, that I must consider every such vibration as a moderate spark. I see that certainly each of these vibrations is excited only by a minimal particle of the excess or deficiency of electric fire, which should accumulate in the conducting wire during small intervals of time, and which cannot accumulate due to imperfect insulation. This great imperfection of insulation I conjecture not only from the quality of the resin and from the humid, cold veil that I think I must invert the glass, but also from the immediate experiment, because, as I said, the hairs vibrate on my fingers as frequently as I wish, and yet, no matter how long I take to explore the hairs and the conducting wire, I never find any spark in it. 400. Considering all these things attentively, I see that, just as clouds bring rain, and snowy clouds bring snow, so too they agree in proportionally bringing the same materials of their same formative cause. Although that formative cause in snow, then, in the admirable figure, and in the most orderly structure of its flakes, leaves us with, as it were imprinted, particular vivid vestiges of its operation. Allow me, most honorable sir, to briefly say a few words about a phenomenon observed by many, but always new to my eyes, and here very opportune to the matter I am discussing. For 10 years I have been observing that here in Turin it rarely snows, and that the common and well-known snowflakes do not fall without intermixed flakes formed like stars or rosettes, as Donato Raffetti, who was precisely here in Turin in the year 1681, was pleased to call them in his treatise on snow. Often the flakes are so shaped for the most part, and sometimes there are no other flakes except rosettes or fragments of rosettes 3-3. Universally, the rosettes are compact, like leaves, similar and equal, distributed similarly around a center and a medium plane. R4, the size, thickness, contour, and ornamentation of the leaves and of the entire rosette are likewise conforming in the common rosettes of the same snow. But in the rosettes of different snows they vary infinitely, except for a few monstrous little rosettes, always following the law of symmetry, so that the various accidental forms are similar and disposed similarly in each of the 6 leaves and in the 2 lateral parts composing each leaf. There are rosettes of opaque frost, there are rosettes of transparent frost, there are thousands of rosettes of opaque frost, and in a certain way adorned with transparent frost, and vice versa. But just as the whole rosettes, So the frosted lace always aims at a hexagonal figure, and this with infinite variety. Zeet starts in the snowflakes that at first glance do not appear to have any certain order upon careful observation. One can also see order and variety. The snowflakes, which are similar to small pellets. The flakes of some snows are like a collection of scales. The flakes of some others are like poorly joined pellets. Sometimes each flake resembles a small curl. Sometimes the whole snow looks like tiny pimples. Sometimes it consists of small cups. Sometimes of very minute points. And although the commonality of the flakes or of the parts, whatever components the snow may have, always has a uniformity in form, still the flakes, or the parts of each new snow, always present some novelty in their structure. 403. This infinite variety tempered by a cohesive rule whenever I contemplate it. I never cease to admire the infinite eternal wisdom even in that neglected production. And I admire it all the more because I see that it creates so much order and so much diversity with the simplest electrical element, with which it produces countless other effects. 404. And meanwhile, who with attentive eyes could behold that most admirable spectacle of order and endless variety without attributing it to formative causes, such as specific gravity altered, or the pressure of winds, or their direction in opposite parts. Specific gravity must create the union that otherwise occurs, and cause the vapors to fall united in flakes and frozen. But certainly it neither creates by itself, nor does it produce the union. And the air or any other fluid that externally presses, how could it ever exert so many pressures around so many different centers as there are snowflakes forming in a cloud? And how could such a fluid press against itself around each center with such opposite directions, resulting in the same rosettes placed at equal angles and with symmetry and with inimitable order? 405. But as for producing those admirable effects, the causes adduced are found inadequate and insufficient, just as I firmly believe in the natural operation of the active element, which internally animates and governs the material object of the same effects. The electric fire which manifests itself in the snowy clouds internally spreads through itself, and just as it spreads itself equally, so must it distribute the vapors which, and by means of which, it spreads from the vapors, in which it abounds through as many points as it can, either into other vapors or into the earth or elsewhere. And for each point to which it can equally direct itself to its end, it spreads equally each time. And at different times, it spreads for each point in a quantity so much greater as its total excess is greater. Thus, in each of the points through which it spreads, it does so in a quantity of particles proportional to its quantity. And it draws them from every side equally, and just as the particles are found distributed in every contour according to the law of equality, it draws them from every side and unites them equally and similarly. 406. And to clarify to myself those attracted things with some sensible example, I often attach to the chain a large piece of cardboard, from which hang many thin threads, each equally distant from the others. And I first take pleasure in observing how, as soon as the said threads are animated by electric fire, they all equally disperse. Then, presenting a finger to one of the middle threads, not without delight, I watch how that one particularly directs itself towards the finger, and the threads that surround it from every side come together just like to their center. And thus, in that unique gathering of a few threads, I clearly revive in what manner and with what law the electric fire animating a snowy cloud must similarly gather many vapors of that cloud for himself. If, then, I were to consider more attentively 325 thus, in which the repellent element which animates the vapors must distribute them, what is the law by which it must attract and unite them, while it transmits them in particular quantity through any point that happens to have a particular inequality of electricity compared to other nearby points? Here's the individual reason that presents itself to, for which in the marvelous snowflakes which it gathers and fabricates, it must so singularly aim at the hexagonal shape. 403. To investigate that reason, we need no other principle than that which is entirely consistent with experience, namely that the electric fire, which equally animates the vapors of a cloud, must repel them equally and must contain each one at equal distances from each other, which can immediately surround it. Thus, such a principle must exist on a surface regarding the order of distances of each vapor with respect to each other. Each vapor must form an equilateral triangle with each pair of vapors that immediately surround it. Therefore, if each vapor connects with straight lines to each of the other vapors that surround it, i.e., each vapor will be found as a center enclosed in a series of concentric and parallel hexagons, the radii of which will progress according to the series of natural numbers. The vapors will be distributed in the first hexagon, that is, one at the apex of each angle 3. 12 in the second hexagon, that is, 6 at the angles and then 6 at the points that divide each side into 2 equal parts. 18 the third hexagon, that is, 6 at the angles and 12 at the points that divide each side into 3 equal parts. 24 in the fourth hexagon, that is, 6 at the angles and 18 at the points that divide each side into 4 equal parts, and so on. 409. Must be the arrangement of each vapor with respect to each other on a surface equally animated by the electric fire. If we can arrange ourselves in consideration of such a superficial arrangement, it seems to me that I can demonstrate as clearly as in it operating, and by it spreading the operation of the electric fire, it can produce the admirable snowflakes. 410. Let us suppose, then, that some of the vapors disposed on the described surface come to communicate particularly with some series of external vapors animated unequally by the electric fire. It will follow that it will remain unequally electric with respect to the surrounding vapors, and that consequently it will first attract those vapors that immediately surround it, and that it will attract them equally as all equally distant, and that it will distribute them around itself at equal intervals, corresponding to the equal intervals in which they were one with respect to the other, hexagonally and in a flat plane. Those vapors continuing their center to communicate particularly will remain unequally electric with respect to the other vapors in direct contact at the angles of the second hexagon, and thus they will attract to themselves, just as the first ones were drawn from the center, and the third ones will similarly attract the fourth one. And in this way, all the vapors in direct contact with the central vapor at the angles of the successive hexagons will unite successively, and will form as if they were equal rays of a hexagon. The vapors that were disposed orderly in the successive sides of the second, third, fourth, etc. hexagon first 1, that is 1 for each side, and then 12, that is 2 for each side, then 18, that is 3 for each side, then 18, that is 3 for each side. Should they not all distribute themselves orderly, and some, that is those that alternatively find themselves in the middle of the sides, should rush toward the center, thus filling toward the center the intervals of the rays, and some, that is, those that find themselves similarly disposed and in equal number toward the extremity of the sides, should rush in equal number to their neighboring rays, thus composing around them the equal and similar parts of each leaf of the snowflake, and all those things which we cannot represent, that with many words and in a short time the electric fire, which in a certain way we intend to understand, discharges from ample spaces into other ample spaces. Should it not produce them in a certain way? 411. Nor is this all, but the other accidents also, which are infinitely varied and are all wonderfully remarkable, find in that producing principle such a natural explanation, which can be brought to few other phenomena of nature, and primarily, the various sizes of the snowflakes must correspond to each of the vapors of the described surface, so that the greater quantity of vapors must gather around it. The more fire it must discharge through itself between the surface and the external vapors with which that vapor will come to communicate particularly, and thus proportionately larger snowflakes must result. Just as precisely for the infinitely greater electricity that dominates in the hailstones, a quantity of vapors infinitely greater gathers around the central nucleus, 412, and thus, as the diverse quantity of fire creates the diverse size, so the unequal diffusion of it must not create a varied contour, a varied ornament. To better clarify those accidents, it seems very valuable that I should present some consideration. Universally, the electric fire, which discharges from one body to another, attracts and unites a greater number of bodies, and unites them with greater force in proportion to the greater quantity it discharges. Thus, in proportion to how strongly it electrifies, the greater number of bells vibrate to it, and they vibrate to it more strongly. According to such a principle, the most copious electric fire unites infinitely many vapors in each grain of hail and densifies them maximally. The small force that the little fire producing the snow has does not unite relatively more than a few vapors in each snowflake, and it unites them with such rarity that it leaves between them infinitely small intervals. Now, the ornament of the snowflakes usually reduces to certain rows or mirrors of crystalline and transparent parts, which embroider the opaque body of the snowflake in infinitely varied ways, but always with a very similar symmetry with respect to their center, or to certain rows or opaque spots, which similarly embroider the transparent body. Now the impulse of the electric fire a bit greater. Is it not that which must densify the vapors more and form them into either the transparent rows, or even the whole body, just as the maximum impulse of the fire in the hail densifies all parts maximally? And is the weaker electric fire not that which must more weakly attract the vapors and leave either the whole body or some rows in a greater rarity, and however rapid the flow of the fire may be by which a snowflake is formed? Can it not? Indeed, must it not occur with some inequality, so that in some instant of that very small time a greater or lesser quantity flows, corresponding to the unequal communication that the central vapor may then have? And will that not be enough for the equidistant vapors at that instant to strike more or less strongly toward the center, to condense more or less, and to form a hexagonal and very orderly ornament of transparent rows and specks, or of opaque rows or spots? For under 13, I see well that I proceed in this explanation, starting from a principle that may seem insufficient, because I have solely assumed the position that the vapors distributed by its electrical body must have on a surface, when certainly the electric fire, in forming the clouds, distributes the vapors according to every dimension. But should it not also consider the entire body of the external vapors as a fluid of many surfaces all similar to the described surface? 414. Starting from the same principle, it is worth saying that the electric fire, which equally animates the vapors of a cloud, must repel them all equally and contain each one at an equal distance from each other, which can immediately surround it. I see that even in a body of vapors there must be a progression of order which they have on a surface. That is, each vapor must form an equilateral triangle with all the vapors that can immediately surround it in every dimension. Consequently, for each vapor, 4 surfaces must touch all those similar to the described one, in such a direction that each one inclines from each other by an angle of 60 degrees. Therefore, the entire body of vapors, according to 4 planes, that is, according to the positions of the 4 surfaces that pass through each vapor, will always form a texture of parallel surfaces all similar to the described one, positioned in such a way that the vapors of one correspond alternately to the centers of the triangles of the adjacent parallel surface. 415, moreover. Such is the manner in which the electric fire must distribute a body of vapors until it animates them all equally. But when and where some vapors, due to some particular communication, become unequally electric with respect to the contiguous ones, should it not change their disposition among the unequally electric vapors? Should not the vapors on one surface direct themselves orderly towards the vapors of the contiguous surface, with respect to which those become unequally electric? And thus, should they not unite in one surface and in a row, the vapors distributed in many with the same law, as we have seen them unite the vapors distributed in a single surface? And indeed, is that union of many surfaces into one not necessary to form the thickness that in the worst part of the flakes is already sensible? And in so much, the greater ease with which the electric fire excited by the particular communication will encounter in spreading for the breadth of the parallel surfaces more than in passing from one to another of the same surfaces, will it not gather from a few planes many vapors into one plane, whose breadth has correspondingly great proportion to the thickness, 416. Two observations, among many others, particularly suitable to confirm this entire theory. The first is of the double flakes. The second, of which I do not know if anyone else has spoken, I will call the observation of the snowflakes. The double flakes, as the name indicates, are two flakes united by means of a subtle and short cylinder, which normally connects their centers and holds the leaves, and indeed the little bumps, and all the individuals adorned with both flakes, because I have always encountered seeing the two flakes quite similar, in perfect parallelism. The snowflakes, in truth, are simple, but they have a small conical tuft which unites at the center of the flakes with its tip, and is normal to their plane and spreads its base outward. Whenever the snow falls in the shape of flakes, I've been able to observe some double flakes. I did not notice the snowflakes in the last snow, which I observed last year. And in that winter I saw many in two snowfalls, 417. Now, in the particular accidents of those two flakes, I revive as the vestiges of the two particular manners in which the electric fire must gather the vapors, which are found distributed in the manner I have described. In the first observation, I revive the electric fire, which spreads normally from some parallel surfaces into other parallel surfaces to those, and parallel to each other. The small cylinder appears to me the result of the vapors that have induced the particular communication between the two strata of the mentioned parallel surfaces. The parallelism and the perfect similarity of the flakes represent to me the parallelism of the said strata, the similar manner in which the vapors have been distributed in them, and the similar and equal manner with which the electric fire gathers the particles when they are equally disposed, both those from which it exits and those into which it enters. 418. But then in the second observation, I seem to see the electric fire, which through three of the four surfaces, which, as I said above, intersect in each vapor, spreads around the vapors distributed in the fourth surface, and from the three surfaces which converge towards the fourth, and form with it and among themselves an angle of 60 degrees, it gathers some vapors to form the small cone, and from the plane of the fourth gathers from every side the necessary vapors to form the flake. 419. But in summary, the construction of the flakes depends on a particular disposition of the vapors, which forms for each vapor a network of equilateral triangles, and also depends on the particular direction of the electric fire, which spreads, as if from a center according to the breadth of one or more parallel surfaces forming the said network. If, then, the direction of the electric fire changes significantly, will it not bring about other innumerable forms and figures for the tufts? If the electric fire gathers equally around a vapor, the vapors that are distributed in the four surfaces, which intersect in each vapor, should it not result in snow with small grains or with little balls? But what variety of tufts should not result if, in addition to the varying direction of the fire, the disposition of the vapors for which it must also direct itself changes? I have sought the disposition that I must have for the vapors, provided they are fixed points, that neither for the reason of shape nor for the reason of thickness, but they should produce a proportional difference both in the disposition of the vapors and in the manner of their gathering. Indeed, the mere diverse quantity of the electric fire that gathers should induce a great variety even in the shape of the gathered vapors. Donato Rossetti, in his treatise on the shape of snow, states that he has seen grains of gruppel from which angles protruded in various directions, forming a plane. This observation can also serve to connect snow with gruppel and to subordinate those apparently disparate effects to a single efficient principle. However, the ordinary shape of gruppel, which tends toward roundness, will prove that the only differing quantity and strength of the same principle must produce such a great variety in the shape of the snow itself. A more copious and therefore more vigorous electric fire should spread more widely in every direction more rapidly, and in a manner we might understand as more tumultuous. It is observed that coarser gruppel has a less regular shape. A similar situation will proportionally occur in snow. A bit more vivacity in the fire that forms the snow will aim to round its flakes, or even to complicate their shape so much that no unit of regularity can be discerned. Proposition 22. The emphatic meteors contribute to proving that there is a principle that orders and arranges the vapors and the raindrops, etc., with great regularity and with a certain law of uniformity. And all find in this principle a more complete explanation. 420. I have dared to delve somewhat into the minutiae and almost to geometrize regarding the order and arrangement of the vapors. Not because I universally enjoy this method of philosophizing, which, as it is often enlightening, is equally often vain, but solely because I have been led by the subject in which nature manifestly geometrizes, and simply with the simplest force of a diffusive element. 421. Nor are the most regular accidents of aqueous meteors, namely the union and uniformity of clouds and the order of drops in rain, and the order and geometric shape of snowflakes, the only phenomena, but moreover, all the astonishing accidents of emphatic meteors demonstrate to me the operation of an active principle that aims to arrange the vapors and to condense them uniformly with universal rule and with truly geometric order. 400. In fact, the colored halos that surround the sun, the moon, the planets, and the stars, when the air is calm and is scattered with rare vapors, the colored circles that appear around the sun or encircle the observer's head during certain occasions, certainly indicate a consistent uniformity, both in thickness and in shape, and in the intervals of all the vapors in which light is so orderly refracted, as is necessary to produce such orderly appearances. Universally, every most subtle zone of any colored emphatic circle to appear uniform in every part and in quality and in vividness of color, must refract the light equally in every part and refract an equal quantity in every part. And this certainly requires and demands a uniformity in the accidents of all the vapors and in their portions, and since different observers see the same zone in different places, it is certainly necessary that this uniformity spreads widely throughout the series of vapors. 423. Moreover, the most beautiful colors of the rainbow, which are directed to our eyes, not so much from distant vapors as from minute droplets, in which the vapors that compose some drizzle are gathered, manifestly prove that a great order must reign in all the accidents of thickness, shape, intervals of time, and place in the droplets of the same drizzle. 424. To such meteors, I wish to relate the representations of terrestrial objects that at certain times appear in the atmosphere, which, as far as I know, have thus far been equally admired by the public and neglected by philosophers. The inhabitants of the coastal regions at certain particular times frequently see the summits of distant mountains, and they see them floating in the air. The Reverend Roger Boscovich, a distinguished mathematician of the Society of Jesus, in his learned and useful book, De Expeditione Literaria Perditionem Ponti, states that he has often observed such astonishing appearances, both in the Tyrrhenian Sea and in the Adriatic. It is perhaps even more remarkable the appearance that Dr. Andreas Spohl recounts in the 5th number of the Philosophical Actions. He states that one morning he happened to see from a hill the surface of the nearby Lake Vetrano, a vivid image of the island of Visingburg, even to the point of discerning the windows and the people. From that hill, however, he should not have been able to see the said island directly, because it was very far away. Nor could he see it directly because some hills were interposed between his eye and the said island. The observer notes that his eye was in the middle of the shining sun and the place of the lake in which the island was represented. No less curious is the fact that happened to Father Boscovich, who, having seen excellently from the place of a signal erected toward Rimini, another signal erected toward Pizarro, from that place could not discern the latter until he went up a ladder, and going up it, he did not see the signal gradually emerging from the water, but he saw it all at once, although at first he saw it confusedly, as if through a fog, and directed almost in a line. Then, as he went higher, he saw it more clearly, until at a certain height he saw it with its natural width and shape. The corresponding successive appearances that Father Boscovich had regarding the buildings and the sails of the ships that were near the signals. Now, whatever the individual causes of these appearances may be, They certainly depend on some strange reflections or refractions that occur in the atmosphere from the rays proceeding from the terrestrial object. But pure air is not likely to modify light so dramatically, because the same appearances do not always return in every serene air. On the other hand, the observation of Father Boscovich, as if through a fog, and the circumstance of the calm air noted by Dr. Spohl confirmed that during such observations there are scattered vapors in the atmosphere which produce those strange reflections of light. But the vapors that strangely modify the rays of light, and modify them so orderly so that an image of the object is formed, must not be distributed in the atmosphere with a certain order and law. To which principle can we attribute such an appropriate distribution, if not to the element that we see universally conduct, direct, and distribute the vapors, and that guides its nature no less those that it itself, the air with corresponding force, 3n, and that it is the same electric fire that draws the vapors together, and excites the winds that accompany the formation of clouds, 432. Thus, I conclude that the electric fire, which acts in the atmosphere, is the primary cause of the phenomena we observe during storms. It is this force that not only generates the clouds, but also influences the winds, creating the rapid changes in weather that we experience. The relationship between the electric fire and the formation of clouds is evident, as is the connection between the clouds and the winds that arise from them. 433. In summary, the observations I have made and the reasoning I have presented led to the understanding that the electric fire plays a crucial role in atmospheric phenomena. It is responsible for the movement of vapors, the formation of clouds, and the winds that accompany storms. This understanding is essential for further studies in meteorology and the science of electricity, as it provides a foundation for exploring the intricate relationships between these elements in nature. The air from the place of the cloud to which such clouds are drawn, and thus produces the stormy wind, more or less impetuous, guiding the more or less impetuous manner of such attraction, that is to say, guiding the greater or lesser force with which the electric fire is expressed and guiding the greater or lesser quantity of it. 432. The sole explanation of that first, simplest, stormy wind contains within itself the explanation of the various accidents, from which it either arises at the beginning or at least during the course of the storm. It becomes even more common. Thus, 1. Since every attraction is reciprocal, and while the separated clouds are drawn towards the primary storm cloud, that cloud is drawn towards them reciprocally. Hence, the wind partly arises from the attraction of the clouds to the cloud, partly from the approach of the cloud itself. 2. And universally, since the circulation of the electric fire in the storm frequently and rapidly changes in strength and direction. It also changes correspondingly in strength and direction the movement of the clouds and vapors. Hence it is that in correspondence to such changes, the stormy winds frequently and rapidly change in strength and direction. 433. I do not dare to present an image of the winds excited by the stormy electric fire in the well-known electric aura. That aura is quite tenuous, just as the quantity and strength of the fire that excites it are tenuous, and consists of a motion of air that circulates, while the stormy winds are a strong and forceful transport of the air surrounding the cloud or the primary storm cloud. Moreover, if one wishes to concede a little to reason, I think that one can very well recognize in the cause of that aura the efficient cause of those winds. Therefore, let me briefly present a few things about it, most honorable so. 434. The electric fire which I push in a conductor causes all the air of a very high and long chamber to circulate around it. For after I have for some time rubbed the globe, I see it moving around the same chamber with a long rod in hand, from whose top hang 2 wires, and I take pleasure in observing how they diverge at an angle of 15, 20, 30, and sometimes more degrees. According to what I have written in another demonstration, all the air of the chamber is imbued with an excessive quantity of electric fire, which my large insulated conductor has pushed into it. How this occurs is partly understood from the fact, partly from the electric aura that accompanies the very fact. The fire that I push into the conductor partly attaches itself to the surrounding air. The new fire that I continue to push displaces the air already imbued with excessive fire, and thus causes other air, not yet electrified, to enter. This continuous displacement of electrified air and this continuous corresponding influx of non-electrified air produce the electric aura and ensure that practically all the air of the chamber is found to be electrified. 435. Now suppose that the electric fire circulates in an incredibly greater quantity. Suppose that the electric fire attracts a large quantity of vapors along its path, which are widely scattered around the same path. Suppose that after having drawn them in, it does not push them away otherwise, but arranges them along its path to form a suitable conductor. Suppose that it continues to attract more and more vapors and to expand its conductor proportionally to its quantity. Is it not true that in such a case the electric aura will degenerate into a following wind? Just as other vapors will always be drawn into the path of the circulating fire, so too will other air be continuously pushed around from the place of the same path. 436. And such is the case of the stormy electric fire. It attracts, in the space through which it circulates, more and more vapors, and thus creates the cloud and the storm, and they in turn heat the space of its circulation and expand. And by continuing to attract and retain more and more vapors, the stormy wind excites and produces. But indeed, to see the cause of the stormy winds and the cause of the electric aura, one needs an eye that can discern the playful sparks from the terminating lightning. And in a conductor of a few feet, contemplate the clouds extending for many miles, and to the attraction and repulsion of a little air, constitute an attractive force of clouds and infinite vapors. To confirm with the observation, the unity of the theory established in this letter for the various meteors as follows. 437. As I conclude this letter, a very pertinent observation presents itself to me, as I think, to confirm the sum of what I have explained in it. Yesterday, February 25th, 1758, at 3 o'clock in the afternoon, I observed towards the east a cloud, which besides the color of the sky appeared to me to be stormy. I saw corresponding to the dark body of that cloud various white clouds, which were slowly diminishing and disappearing into the same cloud. The entire sky was scattered with separated clouds, very irregular. At first, the clouds from the east and the north had a direction towards the wide side of the same cloud, and I observed that they were gradually uniting with the cloud from opposite sides. Suddenly I noticed that a cool wind was coming from the cloud towards me. Thus, the union of the clouds was spreading more widely, both in those that were towards the east and towards the north, as well as in many others that were scattered across the sky between east, southeast, northwest, and my zenith. Meanwhile, the cloud was approaching or extending towards me, and the wind was increasing in the same direction. While I was retreating into the city, that is to say, in a few minutes, the entire sky was filled with a unified dark cloud. Upon reaching the porticos of the Po district, I found the people attentive to that stormy cloud, and out of season. It was not long before 3 thunderclaps were heard towards the west. Immediately hail fell, the grains of which were as large as chickpeas in thickness, and made a sound against the windows. In less than a minute, the hail turned into mere rain. Initially a bit rough, but soon quite calm. It lasted a few minutes and quickly changed into snow, so that upon returning home I had the pleasure of seeing myself covered with a mantle of many stars. At the Hermitage, which is to the east of the hill of Turin, the same occurred, with this only difference, that there the snow fell to a height of a foot, 438. I dare to establish a proposition from this observation, because although rare, I trust that it will not be unique, and that others may observe the same elsewhere, which the people here observed yesterday in such an observation. I have seen how nature has united what theory led me to connect and subordinate to the efficient principle itself, namely the cloud, the progression of the cloud, and the separated cloud, their union, the wind, the thunder, the hail, the rain, and the snow. 439. I would have wished to be at the electrical observatory to see what changes in electricity corresponded to the alterations of all the aforementioned successive meteors, however. The observations I have repeatedly made on them separately and the Felicina of all the successive circumstances that varied gradually in that observation indicate that the variation of the same meteors is sufficiently evident that their continuous gradation proceeds from the continuous and successive gradation of the quantity and strength of the circulating electric fire. 440. In fact, the operation of the electrical element greatly extends to produce fiery meteors as their proper and active matter, and to animate the waters and some parts of the winds, thus becoming their motor principle, and to arrange thus their principle, establishing the uniform medium in which light can appropriately represent the emphatic. In these matters, although I believe I have advanced beyond what is commonly opined in the investigation of truth, it is not that I do not clearly see how much remains to be explored in order to lead such knowledge to the degree of perfection that we humans can achieve. 441. Is the aerial electricity that I have found in artificial electricity not equally necessary in the natural electricity of the atmosphere? I have elsewhere demonstrated that the perpetual small and interrupted flashes from long and high conducting wires do not arise from the tropic or from any alteration of vapors. Is it not the air which, finding itself to have a measure of fire disproportionate to the fire of terrestrial bodies, justly, by its nature, unites the measure of its fire with the wires, so that they sparkling unite it with the finger of the observer? 442. Is not the cause and the law of that aerial electricity the same as the cause and the law of the electricity proper to the united clouds, rain, thunderstorms, etc.? The electric fire that animates the terrestrial globe by its natural force perpetually disperses against the air, which is like the restraint, the most powerful. And in fact, I have experimentally shown how the air is imbued with such fire. But the terrestrial electric fire always disperses at the same time from various parts, and always at different times from the same part with some difference in strength. And therefore the fire of the air, which neither gives nor receives the electric fire, is found to be slowly disproportionate to the fire of the earth, when the differences in the fire that disperses from different parts of the earth are greater, so that it reaches to form a conductor and to circulate freely from places of greater strength to places of lesser strength. Then it is that it clouds, flashes, thunders, and produces proportionately hail, rain, and snow. When such differences are smaller, so that its slight imbalance does not reach to form a continuous conductor between the terms of less unequal strength, then it is that, where in the earth it overflows, it reflects to the air. It leaps from the earth and slowly affixes itself to the air of the atmosphere, just as the fire of my conductor affixes itself to the air of my room, where it overflows in the air with respect to the earth. It slowly disperses from the air and spreads into the earth, similarly to how the fire of the air in my room slowly disperses from it and spreads into my machine. 443. And such natural aerial electricity should it not naturally produce in the atmosphere effects similar to those produced in experiments by artificial electricity of a similar nature. Now I have advanced that the air is electric by origin similarly to glass and resins, and glass and resins have that property, that they attract to themselves the small bodies that are conducted, with respect to which they have some small difference in electric fire, and they flatten them, unify them, and in a certain way glue them to their surface. And even after having united their fire with them, they retain them so cohesively united. And why then should the air not attract, nor unite similarly to itself the vapors, with respect to which it finds itself to have some unequal measure of its electric fire? Why, even after having united its fire with them, will it not hold them similarly united? Here, if I am not mistaken, are the principles with which one wishes to explain both the serene sky and the vaporous sky, and the separated clouds and the sluggish and inert mists. 444. Whenever the aerial electricity, that is, the difference between the electric fire of the earth and the electric fire of the air, progresses in small degrees and uniformly through a wide and high space of the atmosphere, it will similarly progress in this compartment and the tenuity of the vapors, and therefore they will not completely diminish, but will only dilute the purest cerulean color, forming a sky more or less vaporous. According to the greater or lesser value of this aerial electric electricity, 445, When and where the aerial electricity progresses very unevenly, there the air will imbibe vapors very differently. Those volumes of air that will have a measure of fire more disproportionate to the fire of the vapors will imbibe them more copiously, and in this way the separated clouds will form. That is to say, the clouds that, without forming a single body and maintaining each its own limits, are often seen to emerge separately in the atmosphere, but remain in correspondence with the mountains and remain thus separated for a long time. 446. The genesis of the uneven aerial electricity and of the separated clouds that result from it can be distinctly observed, especially in summer when one sees emerging clouds that are high and narrow, which the people commonly call cartelli, and which they consider as thunderstorms due to their consequences. Such clouds, when they rise very slowly, tend to end by forming separated clouds, which the electric fire, which slowly excites and promotes them, does nothing but induce a very strong aerial electricity. That is, it affixes to the air, and to the air itself affixes copious vapors. 447. Hence, such separated clouds give to the conducting wires only small and interrupted sparks, which must proceed from a particular aerial electricity. 448. It also happens for the same reason that such clouds, as long as they remain thus separated, do not turn into water, because each component vapor, even after the air has united its fire with it, remains affixed to its particle of air, and therefore each remains separated from each other. And it proceeds from the same principle, the universal inertia, with which the clouds universally do not disperse, except very slowly, and resist even to the winds that pass through them. 449. If the electric fire draws more copiously and more quickly from the ground, in addition to the part that will attach to the air, another part will form a free current that will draw more abundant vapors along its path, will unite them more broadly, will attract other dispersed clouds, will place each vapor in a position to form the suitable conductor, and will freely and progressively discharge them from the particles of the air. It will be able to condense them, and will be able to form rain, hail, and snow. 450. Such a free current detaching from the air and returning the vapors dispersed in the atmosphere will restore to it its native limpid celestial color. 451. And do the low, sluggish, and murky mists not also depend in part on aerial electricity? It suffices for me to consider that neither the fire nor the walls nor the face of my room prevent me from electrifying the air contained within it very durably. For I see how even in contact with the ground, an aerial electricity can dominate, excite, govern, and spread the aforementioned mists. 452. Certainly among the many effects that aerial electricity can produce, this one is explored and extends very broadly, that all vapors or breaths, whatever their cause, that either rise in the atmosphere or float in it, or descend through it must be affected by aerial electricity in their breath, in their absolute as well as their respective movements. Thus, for example, many astonishing phenomena of dew, of drizzle, and of frost, the directing of their droplets, their trajectories towards certain particular bodies, the directing from every direction and in every manner, the directing particularly towards corners, edges, and points, are phenomena which, as I explained suitably by supposing some perpetual electricity in the atmosphere. So now, after demonstrating its efficiency, I see that they must necessarily occur. Question I-453. Would not the alterations in the gravity of the air also be proven by the alterations in the winds? I have observed that stormy winds affect the pressure of the air on the surface of the earth. This barometer consists of a long glass tube that extends from the bottom of a large flask through its neck, to which it is carefully sealed. Rising to a height of 2 feet or more, by blowing into the tube, I force the air from the flask, causing it to raise part of the water contained at the bottom of the flask. Now I have observed that corresponding to a wave of stormy wind. The column of water in the tube lowers according to the greater or lesser force of the wave. But despite this observation, I do not feel compelled to recognize in the action of the winds the main cause of the barometric variations. 454. because the most consistent law that I recognize in such variations is that mercury rises in proportion to the rain. During the rain it falls, and in fair weather it rises again. Now, that law seems to me to have a more consistent and necessary relationship to the changes in atmospheric electricity than to the winds. I often see the mercury fall in proportion to the rain, while the air is in great calm. Many times I have observed clouds rushing towards my zenith, and they are forming the storm while the mercury falls. In the first case, the efficiency of the cause is lacking in relation to the effect. In the second case, the cause should produce a contrary effect, since if the clouds rushing to my zenith were coming from the winds, they would accumulate the air above me, and the mercury would rise. 455. Therefore, changes in weather are consistently accompanied by changes in electricity in the atmosphere, and those changes must necessarily influence the alteration of the air pressure. 456. I have examined whether it is more appropriate to attribute such an effect to the electricity inherent in the clouds, or to the aerial electricity. The latter, since it should progress more slowly and gradually in its alterations, seems to me more suitable. However, I have not hesitated to explore the efficiency of the former. 457. Thus, several times during horrendously thunderous storms, I have attentively watched the tube of the barometer, and 3 times in the instance of certain nearby vivid phenomena, I have seen the column of water vibrate downwards in some lines. From this I concluded that the electric fire which freely discharges through the clouds cannot otherwise be the cause of the barometric variations, because if a lightning bolt discharges or charges an entire body of storm clouds, it does not raise the water, but only a few lines in the sensitive barometer. The form of the alterations that the mercury undergoes being limited to 1.5 inches certainly cannot be attributed to the electric fire which the clouds animate and thus discharge. 458. The fire, which extraordinarily spreads forcefully in the air and partly attaches to it, seems to me, as I said, more suited to raise the pressure. The electric fire, which flows altogether from my large conductor into my device, does nothing but move the small column of air through which the electric fire passes, which effectively and continuously, not finding another outlet, forces itself to spread from the conductor into the surrounding air, effectively pushing it away in proportion to how effectively it saturates it. And I think that this does not happen without the electric fire affecting some part of the weight of the air. 459. Now, when the weather is inclined towards rain, the electric fire, which begins to discharge in an extraordinary abundance from the ground, must load the air before it reaches to discharge freely, and before it reaches to form the subsequent conductors. It must push the air in a certain way and affect part of its weight. Then, once the clouds are formed, their continued communication, the rain, and the winds will adequately connect the fire with the ground, for which the air was particularly pushed and charged, and once every circulation is finished, there will no longer be a particular return of fire that particularly affects the pressure of the air. And in this way, necessarily, such pressure will rise in proportion to the rain. During the rain, it will recover its degree of strength, and in fair weather it will maintain its usual degree. 460. But in that hypothesis, the pressure of the air should seem either that the air is fully charged with electric fire from the ground, or that it is partly stripped of the fire from the ground. Would not the electric movements exemplify and prove the possibility of the fact equally in the second case as in the first? Just as the small bodies are repelled by the machine equally by the defective electricity as by the chain through the excellent electricity, could be similarly derived from the electric fire abundantly produced by the earth, and from the electric fire that in itself abundantly generates in relation to the earth. Question 461. Besides the particular efficiency of aerial electricity in certain aqueous meteors, should we not also consider how heat and rainy winds sometimes cooperate with them? Certainly, the winds that blow from very vaporous regions, whenever they bring vapors into any area that is animated by an unequal measure of electric fire, will cooperate to induce a continuous circulation of these vapors, so that they will abundantly spread out between various terms. The wind will directly carry between these terms other materials. Thus, the unequal measure of electric fire will effectively distribute, until it refines the continuous conductor, which reduced to a suitable thickness. Will gradually dissolve the circulating fire into water because part of the persistent action of the wind, and sometimes also the action of the already circulating fire, will continue to supply other and other vapors, which will continue to disperse in another and another orderly, fertile rain. 462. Just as the wind cooperates with electric fire by transporting between unequal electric terms the material that it distributes, so heat cooperates with the same fire by lifting a large part of the same material into the atmosphere. The sun from its rising until sometime afternoon impresses new degrees of heat greater on the surface of the earth than in the atmosphere, which is less susceptible. The effective heat also has the property of spreading equally and conducting with it the breaths, the vapors, just as electric fire conducts the particles it carries into the spaces in which it spreads. In this way, the effective heat of the earth lifts and uniformly distributes in the atmosphere a proportionate quantity of vapors, which then become the clouds that are the potential rain of the atmosphere. 463. Towards evening, as the sun sets, and then the action of the sun diminishes, the heat that kept the vapors suspended in the atmosphere begins to wane, and they start to gather and condense. For after the air cools incredibly faster than the surface of the earth, the excess heat persisting in the earth continues to press from it, and sometimes even to lift some vapors. But those that condense, and those that continue to rise, are so effectively restrained by the cold that they return to the terrestrial bodies in the form of indistinguishable droplets, the shape of which forms dew, and that, during the night, lasts, whether it is dew or frost, depending on whether the difference in dominant heat between the earth and the air lasts or diminishes. 464. Towards dawn, a similar cause determines the dew. The sun, which begins to warm the part of the atmosphere in the east, pushes towards us the cold that has accumulated there all night, for whatever the nature of the cold or heat. It is a manifest and constant law that heat pushes away from the place where it spreads the cold and accumulates it in places where it has not yet begun to operate, and thus produces the intense cold that we experience towards dawn, and causes other residual vapors in the atmosphere to condense, and therefore produces dew or morning frost. 465. Here, if I am not mistaken, is how heat operates in the rising and falling of vapors throughout the day. However, all such movements of vapors must certainly be modified, as I have explained above, by the aerial electricity of the atmosphere. It dominates those particles that are perpetually in the atmosphere, nor can the particles that are vapors swim in a medium without participating in its electricity. 466. Moreover, heat supplies a large part of the material for aqueous meteors through daily evaporation. It seems that with its annual variation, it also contributes to varying the material of these meteors. For although Jalillo has observed that in Jamaica it thunders all year round, and Moschembruchio asserts that in Leiden it hails more often in winter than in summer, and here in Piedmont sometimes there is thunder in the heart of winter, still here. And throughout Italy and in Sicily, I observe that thunderstorms generally do not occur, except in summer. And I read that generally the same law applies to other countries. And the aforementioned authors do not assert that the phenomena of thunderstorms will occur with equal impetuosity in winter as in summer. So, considering the universality of the fact, one can conclude that there is some correspondence between summer heat and the more impetuous thunderstorm phenomena. 467. At first, I thought I could explain this correspondence with the common opinion that heat alone can excite electric fire to circulate, and therefore summer heat should proportionately excite a greater and more frequent quantity of it. But upon verifying the common opinion, I was mortified to see its falsity accompanied by the pleasure of discovering how philosophers have been mistaken in their experiments. 468. Sealing wax, pitch, and various mixtures of such substances, and whenever I was careful not to touch these bodies, and not to let them be touched by another body, I never succeeded in obtaining any certain signs of electricity, neither while they were in the state of liquefaction, nor while they were freezing, nor while they were actually cooling, nor after they had cooled. I heated such materials to the sun, at times more, at times less, and whenever I practiced the same precautions, I had the same result of not seeing any sign of electricity. 469. Indeed, and here is the point where philosophers have been mistaken. I have consistently found that a very light touch of any foreign and conducting body tends to excite various signs of electricity in the aforementioned bodies, as long as they are warm and even when they are cool, but in times of very dry air. Thus, for example, merely placing a piece of warm sealing wax on a blanket produces signs of electricity. Merely holding it with a dry hand produces signs. Merely wrapping it in paper does the same. This, I said, is what has led reputable men to claim that liquefaction, which heat alone excites, produces a lasting electricity, but only in the refined substances or in their mixtures suitably enclosed in paper, etc. Such bodies were electrified only by touching them, by wrapping them in paper, by handling them. They attributed to liquefaction, to heat, a lasting electricity which they recently excited among the experiment. 470. In summary, I never failed to observe that just as electric fire is capable of exciting common fire from bodies, so common fire or any heat is sufficient in itself to excite electric fire. Only heat makes it so that the electric fire excited by ordinary causes is more easily excited and remains more isolated, more confined within your limits, and therefore it is more capable of producing the usual signs for ordinary causes, and to produce them more vividly. 471. But do not those effects of heat also concentrate the deficiency or the effect of fire that accumulates in each part of the earth and thus impede the following circulations? And because that, when it finally reaches the ability to circulate and to form suitable conductors, it circulates with greater impetuosity. 472. The observation seems to confirm this conjecture. For indeed the most violent storms are those that occur first after long periods of great heat, and such initial storms must be followed in the subsequent days by others and others less violent, since the first, by mitigating the heat and moderating the humidity, facilitated the path through which smaller accumulations of electric fire could circulate. Question 473. The turbidity, the boiling, the thunder, the lightning, and other such phenomena, along with certain prophetic waters, such a name has been earned by their function, announce the imminent change of season. Primarily the nearby storms, do they not proceed from electric fire, which at such times begins to disturb them strangely underground, from which it is then determined to disperse some part into the atmosphere. 474. The famous spring near Modena, of which Davini writes to the illustrious Valaferi. It seems, says Davini, to have an admirable connection with nature and the atmosphere, flowing clear in dry weather and becoming turbid when the sky is cloudy. Indeed, with its turbidity, it forewarns, and in a certain way predicts the imminent cloudiness. Mr. Antonio Valaferi responds to Davini. It does not make that spring singular in predicting rain. He has noted elsewhere that the mines of sulfur or bitumen, and the springs predict without fail the changes in weather by boiling, thundering, and sometimes lightning before the changes occur. Such phenomena are indeed quite frequent in other places in Modena, namely in the spring of Mount Sibio, in that of Quirzuola, of Cafola, and Umali, or 475. Gian Giacomo Scucero, in a letter to Valafeneri, reports other such examples. He says that the water of the spring of Esti Stefano becomes turbid on the occasion of imminent rain, and remains clear when the sky is about to clear. That the same happens in a certain lake in the county of Stafford, whose surface, moreover, when a storm is approaching, forms a yellowish foam. That also a certain lake evident in Mount Heinzenberg foretells storms with certain murmurs and roars. Similarly, the small but very deep Lake Calandri in the valley of Scamas, before a storm, begins to agitate, swell, and emit such horrendous roars that they can be heard in the opposite mountains and in the valleys up to a distance of 6 hours of travel. 476. Now, does the turbidity of those waters, the agitation at the time when storms arise, not result from the underground electric fire, which begins to disperse from certain bodies that abound in it, and the parts of which mingle with the veins of water, the murmurs, the roars, the thunders, and even the lightning, which, according to the aforementioned observer and observers, precede in such waters, and in the springs before storms. Can they perhaps be attributed to another principle than that which consequently to such thunders and lightning underground then thunders and lightens in the atmosphere? Valafneri's observation that such thunders are most notably felt in sulphurous or bituminous places, does it not show which are the underground bodies from which the temporal electric currents disperse? 477. Philosophers agree in noting from observation that the abundance of igneous and aqueous meteors has a particular and very great relationship to mountainous places, and this seems to be required by the electric meteorological theory, to which I have been adhering in my observations thus far. The mountains on the face of the earth are like the electrodes on a chain and on an electrical machine, through which we see that electric fire strikes or penetrates more easily and more abundantly. It is added that the mountains on the earth are surrounded by an air that is gradually rarer and proportionally less resistant to the electric fire. And furthermore, this particular relationship of aqueous meteors to mountains, at least in part, does not arise precisely from the fact that the mountains are mostly rich in sulphurous and bituminous bodies, 478. Volcanoes also usually emerge from the mountains, and the chain of the highest mountains of our globe is a chain of so many volcanoes. One cannot help but admire that no one until now has profited from an observation that many have made. It is that in the greatest eruptions, volcanoes emit a great quantity of electric fire, 479. Earthquakes have a manifest connection with volcanoes, and they also tend to propagate through the ridges of the mountains, and in them, especially when they are very violent and extend widely, they correspondingly tend to discharge some part of the ruinous fire into the atmosphere. 480. In summary, all the most significant atmospheric and underground alterations show that they have a direct connection with each other, and all seem to have a particular significant relationship to places and to radicino to the number of the aforementioned event. Speaking of the fire of 1698, he reported that from time to time flashes were seen amidst the smoke, and sounds of thunder were heard, along with frequent tremors of the earth and earthquakes. Describing the fire that began on May 14, 1737, he recounts that throughout the duration of it, until May 25th, Vesuvius continuously emitted fiery smoke, ash, stones, and vapor from the flames referred to by the locals as ferilli. This popular name further demonstrates the truth and frequency of the event. In the year of the world, 3071, Paul of Aegina, in his account of Greece, narrates that even after Agesilaus had camped near Argos, the earth did not cease to tremble. Meanwhile, many soldiers were struck by lightning, and many remained stunned and dazed. Licosthenes, in his Chronicle of Wonders, reports that a portion of Mount Parnassus collapsed onto an army. A good part of it was thrown to the ground by a dreadful storm that occurred during the earthquake, accompanied by thunder, lightning, and hail. In the year of Christ, Paul the Deacon narrates that in Constantinople there was an earthquake so dreadful that while the earth trembled beneath their feet, fire was hurled down from the sky. The times to which atmospheric or subterranean circulations of electric fire have a similar relation seem to clearly indicate how they are subordinated to the sole and infinitely varied operation of electricity. 481, however. If I were to continue to elaborate in detail on each of these matters, I would find no end to conjecturing or writing, rather than wandering further into such probable matters. I prefer to focus on and assert that further experience may lead me to other principles. 115. The authors of the English history, 138, narrate that the earthquake of Antioch was immediately preceded by great claps of thunder, 363. The numerous sacred and profane historians who recount the earthquake of Jerusalem, which prevented the Jews from rebuilding the temple, according to the persuasion of Emperor Julian, agree in stating that this earthquake was accompanied by a fiery rain, which, according to some, burst forth from the sky and consumed the tools of the workers. Ecclesiastical authors affirm that there were extremely violent storms, flashes, and lightning preceding the earthquake. Rufinus narrates that a globe of fire, ejected from the workshop of the utensils, was seen to run through the square, darting back and forth rapidly. To these characteristics, which are like definitive signs of electric fire and lightning, Rufinus, Socrates, Sozomen, and others, add another, that the bodies and garments of the Jews were marked with many small images of crosses or stars, as Sozomen called. The author of the dissertation on the project of Emperor Julian reports that in the city of Well a lightning bolt that struck the cathedral left imprints of such small crosses on the bodies of the people. P. Kircher, Works of M. Boyle, Vol. 4, p. 193, reports that in 1660, after an eruption of Vesuvius, similar crosses appeared on the garments of men. 363. In the Theater of Human Life, it is written that after many lightning bolts fell from the sky, the earth trembled horrendously. Govio reports that on the day after a great storm of lightning, the entire earth was shaken. 83. Licosthenes narrates that the earth trembled horrendously, and during that earthquake some lands and country houses were set on fire by lightning. 138. In the Polychronicon of Higden, Book 2, Chapter 8, it is written that the earthquake in England was preceded by great claps of thunder. 3056. Purchas, in his travels, reports that an earthquake in China was preceded by strange rains, that enormous hail fell, 364 of the terrestrial atmospheric electricity. I can write more briefly and more determinately. Moreover, I have already taken too much of your time, most illustrious sir, with the prolixity of these letters, and with their manner, which are neither sufficiently coherent in themselves, nor continuously dispersed from that respect which I still hold in my heart, towards the sublime merits you possess. Yet it does not benefit me to flatter myself that you, most esteemed academic, as a most amiable and well-deserving seeker of truth, will have in place of flattery something more substantial and significant, which I firmly address to you in the investigation of it. The fire from the earth captured the city of Venafan, which was consumed by the fire from the sky, and the city of Iochu was entirely devastated by the fire from heaven. 2561. Bellaboa, in the reports from Avellino, P2 narrates that the earthquake of Avellino was immediately preceded by a torrential rain, hail, thunder, and lightning. 2600. Martino del Rio narrates that during the earthquake of Arequipa, the sky was darkened for a month. At first it seemed that the lightning opened the sky and thundered horrendously, and flaming globes were seen darting here and there. At one point, such a globe fell very close to the temple, from which it shattered in the surrounding public street, where it disappeared, and a great landslide occurred. 3606. Girardi, in the Memoirs of the 17th century, reports that on January 25 in Rome, there were thunder, lightning, and an earthquake. 3685. Salmon, in Volume 3 of Modern History, p. 879, narrates that the earthquake in Jamaica was preceded by a great storm. 2692. In number 29 of the Anglican Transactions, it is written that in Port Royal, Jamaica, the sky, which before the earthquake was serene, during the earthquake appeared as if on fire. 1693. Salmon, in Volume 2 of Modern History, p. 397, reports that in Melfina, while the earth trembled, the air was on fire due to terrible and continuous lightning, accompanied by horrendous thunder. In Ainho, Great Britain, a minute before the earthquake, there was a great clap of thunder. 3010. The Ipswich Journal states that the earthquake in London was preceded by continuous but confused flashes, which occurred 1 or 2 minutes before the earthquake. 3056. Finally, no one has reported how in the part of Alinea, which was finally shaken with Lisbon, there were reports of the earthquake accompanied by strange storms, flashes, and horrendous lightning. I imagine that this very tenuous covering, which I present to you under the title of New Phosphorus, will merit your attention and will serve to entertain your contemplation for some time. It consists of such a covering that the glass struck and brushed by the air shines, and it has this quality that, in addition to the knowledge of the fact, it is at least partly adorned by the knowledge of its cause. 2. The study of electrical things has led me to see glass shine when struck by the air. I had already found and experimentally confirmed that the air is indeed saturated with electric fire. I had often taken pleasure in both increasing and diminishing the quality of such fire as it is confined in small or large chains. I had recognized how such aerial electricity influences extensively all the effects produced by electric fire. When it occurred to me to proceed further to investigate how such fire operates in the very air, and whether it has any essential effect regarding its nature, one part of my numerous attempts has indeed led me to see some things concerning what I had proposed. The other part, which I will now present, has led me to discern the new phosphorus. Eliminating the air in the act of rarefaction seemed to me one of the means that could in some way bring me some light, or at least direct me to experiences of other kinds. And therefore, many times in the darkness of night, I have evacuated some air from a glass bell jar, carefully observing whether in that act any light appeared to me. Several times I have suspended some movable hairs beside the very bell jar. While evacuating it, I watched to see if, at the moment of drawing the vacuum, those hairs would be agitated, and thus I would have some sign of electricity. But I have never succeeded in either producing any light in the dark or observing any movement in light. For I know that you, most illustrious sir, will not be surprised that I have attempted to investigate some novelty in such common experiences. The particular aim reveals the novelty in a common experience that escapes the eye of one who experiments only with the common aim. And although the commonly mentioned experiences have not revealed anything new to me, yet another experience, also very common among children, in which until now nothing similar had been observed regarding the impulse of the air, has demonstrated to me the new phenomenon of the light, which, as far as I know, had not been observed before. 5. Therefore, considering the incredible rapidity with which electric fire, when unbalanced, shatters the equilibrium, and on the other hand, weighing that the bell jar does not evacuate air, except with a certain progression, which, in relation to the said speed of electric fire, is entirely slow, it could well be that there is a movement of fire in such an operation, but that such movement is distributed and imperceptible. I thought either to make a sudden evacuation or to quickly fill a previously made vacuum. 6. And behold, it happened that the childish experiment of glass bombs came to my mind. I have procured several from the furnace, larger than those made for lamps, and letting them fall in the dark, I had the pleasure of seeing that, upon striking the ground, in breaking a momentary light appears, which, in brightness and in width, corresponds to the size of the bombs, and to the space that the air occupies in filling the capacity, which at times is more, at times less evacuated. 7. The brightness, the purity, the color of that light, its rapid excitation and appearance have indeed excited in me the idea that it was truly light from electric fire, and now, after having observed it at least 100 times, I could not better compare it than to the light of certain less brilliant and yellowish flashes that sometimes unfold widely through the air, outside of clouds, at the moment of some lightning, and strike directly the sight, but do not harm it. Furthermore, I have not been deterred by this appearance, and I have endeavored to proceed further to investigate both the quality and the cause that excited it. 8. And primarily, a certain odor like that of smoke, which I noticed spreading from such bombs upon breaking, led me to suspect that the light, which manifested itself at that moment, did not belong to its common cause. The green powder that is usually placed inside such bombs during their manufacture, besides spreading its humid vapors due to the heat of the glass, which constantly expands the glass more and more, also generates a true smoke, which, upon breaking the bomb, spreads and is very distinctly perceived by the sense of smell of those who experiment. I therefore suspected that just as such smoke, after having been confined for any time, still retained the ability to spread at the moment it broke the bomb and to be perceived by the sense of smell, so it would not be that such smoke, as enveloped in its parts, had any residue of common fire, but rather that it was developed by the impact of the air, and in this way could be perceived by sight. 9. Therefore I began to experiment with other bombs, which were made without any other powder used for lamps, nor did they fail to bring me some more tenuous and more difficult to perceive, but certainly certain light. I attributed the tenuity of that light partly to the smaller size of those bombs, which were made by the furnace with a diameter 4 to 5 inches, while those barely exceeded an inch in diameter, certainly the impact. And therefore also the light must proportionately be smaller for that reason. I also doubted that the thinness of the light from those small bombs contributed to the fragility of the glass, which, being very easy to shatter, allows a large part of the air to escape. 10. Furthermore, whenever I broke such small bombs inside a large Majolica cup, holding it not far from my face, and being careful not to close my eyes at the moment of breaking them, I discerned a certain light corresponding to the impact of the blow. And since those bombs are made without any other powder, and therefore do not spread any smoke, I have seen that the light from the other bombs, which are made with the powder, does not depend otherwise on common fire, except in the smoke of the powder confined within, and from the impact of the air it is developed. 11. Moreover, with even brighter light I have erased from my mind that suspicion. I have elongated and narrowed the neck of many glass vessels at the lamp. Having heated them a little, I made them drink a bit of water, and I placed them in the fire at the moment when the vapor of the water was escaping most violently from the narrow orifice of the neck. I have observed them. I found that such small fragments shone at least as brightly as the bombs from the furnace. Therefore, I have now better established that the light from these is not light from fire, which is collected in the smoke. 12. Although in the bombs of the furnace, as well as in those fragments, the operation of common fire does not contribute to expelling the air, could there be any residue of that which in such vessels remained, however, through the impact of the air, it developed. To free myself from that further doubt, I adapted to the neck of the fragments a suitable brass device, by means of which I connected them to the screw of the pneumatic machine. And through this machine I evacuated the air, and thus expelled them into the dark. And such fragments, thus evacuated without the operation of any fire, always produced a very bright light proportional to their size and the strength of their shock. 13. That correspondence between the brightness of the light and the greater or lesser size of the shock has been observed in all the various ways of the experiments I have attempted. Some bombs from the furnace or the lamp in which by some accident a very small crack had formed, when broken, as they were already full, neither produced any shock nor shone otherwise. Some, which broke only when dropped without being shattered, filled with air, which I perceived to enter through the cracks, and similarly did not shine. Some bombs and some fragments, which at first had not been evacuated, but contained little air, shone but very little. 14. After being strongly convinced that the light does not depend on any residue of common fire, and that the light is excited correspondingly and proportionally to the impact of the air, I applied myself to investigate whether such an impact excites the light immediately by itself, or if it excites it only as a means. In that it causes a violent rupture of the glass, from which, as from an immediate cause, the instantaneous light emerges. 15. To discern this, I found the British tears suitable. In them the violent rupture occurs without the impact of air. The violent rupture is evident from the shattering and scattering of them, and from the scattering of the fragments at a distance of many feet. That such a rupture does not occur due to the impact of air was first observed by the esteemed Mr. Dr. Lackey, and I have renewed the experiment several times, that breaking within the evacuated bell jar, such tears shattered with the same force as in the full state, and did not expel any air that would noticeably alter the height of the mercury in the usual gauge. Thus, I have shattered many such tears in various ways, and always in the dark of night, when the pupil was maximally dilated, and I have never seen true light. I had others experiment, and always with the same effect. 16. While experimenting with the British tears, I went back to read what various authors had written about them. I was surprised to see that Mr. Polignaire in his physical experiments states that such tears shine when broken. If the sonorous experiment, he says, of one of those tears breaks in a dark place, a small flame is seen beginning at the place of rupture, which ends towards the top. The fact does not reflect anything to me, and in at least one part does not even correspond to Mr. Polignaire. I should not think that the theory of the subtle matter, which according to him should shatter the tears, has made him perceive light where it was not. Could he ever have had a particular vision by which he could discern any extremely faint light imperceptible to us? He does not mention this, presenting the fact as universal. Probably he did not observe it, but relied on someone else. And, in fact, he certainly could not discern, in any case, where the light began and where it ended, as he also says it is observed. One must consider the rapidity with which the tear shatters to discern the impossibility of such discernment. However it may be, it is certain that men of good will, and we certainly philosophize for the common good of mankind, do not discern any light in the British tears. Therefore, the violent rupture of the glass does not independently excite the perceivable light as it is excited in the bombs. Should not those bubbles be evacuated of air? In shattering the tear, should not the air also precipitate them into such empty spaces, and thus strike the glass that contained them? I have thought that due to such bubbles, there should not occur a considerable impact of air against the glass of the tears. Firstly, because the impact must be smaller in proportion to the smaller empty space. Secondly, because the tear shatters by its own force, as I have shown. That by the impact of the air, the fragments, being in opposite parts, must escape a large part of the impact. And finally, the smallness of the impact, which the air makes against the bubbles of the tear, or rather the fragments of the tear against the surrounding air, is demonstrated to me by the sudden yet very slight noise, if compared to the explosion of the bombs, which the tears themselves make at the moment of shattering. 18. Nevertheless, in order to further separate the violent rupture from the impact of the air, and to see if that could bring me any light without the operation of this, I conducted 2 other tests. Firstly, I shattered many large Bologna carafes in the dark, which had no noticeable bubble in their thick bottom. The fragments scattered away with some force, yet never did the slightest light revive. One alone produced some light, but in truth it was a very thick Bologna carafe and a bomb. I had made it sealed at the furnace, having removed the thickness of the bottom, for which I leave it the name of Bologna carafe. It resembled those carafes, among which some years ago you, most noble sir, sealed with lead and tin, and demonstrated that the said metals thus enclosed, however long they are kept in the vapor of liquefaction by a flame of spirit of wine, do not otherwise change in weight. That unique Bologna carafe or more bomba in the process produced a small light, but just then a small gust of air intervened, as indicated by the small explosion it made. 19. Another test I conducted to examine this was the sole impetuous rupture that produced light, which seemed even more conclusive to me. I broke many phosphoric tears in the dark under the bell jar of the pneumatic machine, after having diligently evacuated the air from the same bell jar. The fragments were always shattered with force against the jar, yet no light was ever observed. Thus I was able to conclude that the sole impetuous rupture, at least that which occurs in the tears, cannot by itself produce light. It remained to see whether any gust of air against any body produced the same effect. The well-known experiment with glass drums came to mind, upon which the air presses down forcefully as it is evacuated. And so, applying this to the pneumatic machine while the air is evacuated, the external air that weighs upon the drum forces it down, ruptures it, and with a strong explosion falls into the drums. Such an experiment, in which the air was supposed to strike both the metallic plate of the pneumatic machine and the glass drum, seemed very suitable to reveal something regarding my question. I performed it many times, and neither I nor many others, who observed at different times, could discern any light, neither on the plate nor on the glass drum. 21. The same lack of visibility in this gust of air seemed to me a principle from which I could proceed to analyze more effectively and comprehensively the cause of the light that I observed both in the bombs and in the flashes. For the difference in effect must certainly arise from the difference in the experiment. Thus, by carefully considering the differences that appear between the experiments of the bombs or the flashes and that of the drums, one should be able to specify more precisely the particular principle by which light is excited in the bombs and in the flashes. 3 differences presented themselves to my mind, which seemed to me to potentially account for the absence of light in the apparatus of the drums, which flashed in the bombs and in the flashes, namely the different force of the blow the different manner of it, and the different material struck. 23. Regarding the first point of difference, I reflected that neither the bombs nor the flashes, which shone, had been evacuated of air as diligently as the drums were before the rupture of the drum. I suspected that perhaps excessive evacuation could hinder the effect of light. Could it be, I reasoned with myself, that the light resulted from the external air, which, when striking, strongly compressed some residual air within the closed glass? And in that case, could excessive evacuation of the glass, since I used strong drums, which did not rupture until much air was evacuated, prevent the light? But repeatedly I dismissed the vanity of such a suspicion. I struck with a finger, and thus ruptured the drum after 10, after 8, after 5, after 3 strong blows, when certainly much air remained within the drum. Yet I never discerned the slightest glimmer. Thus I saw that the light of my phosphorus does not arise from the friction of the air against any measure of residual air, and universally does not depend on the different force with which the air strikes within those drums and within the bomb, or within the flashes. 24. But finally, here are the experiments that have completed my analysis. First, I experimented by placing a twisted glass carafe on the plate of the pneumatic machine and covering it with the usual drum. And when the air reached the point of rupturing the drum and breaking part of the drum, part of the carafe, I had the pleasure of seeing small flashes corresponding to the area occupied by the carafe. 25. Secondly, I similarly placed a twisted glass carafe of the same thickness as that of the drum, and in this case, the gust of air that ruptured both the drum and the carafe did not produce any appearance of light. Thirdly, I experimented by placing under the same drum various sheets of different metals of varying thickness, and I saw nothing. 27. Thus I was able to conclude that the gust of air against metals does not produce light, and that for that reason I saw no light on the metallic plate of the machine when I experimented with those drums. That the gust of air against very thick glass does not produce light, and that for this reason, neither correspondingly to thick glass drums did I see any light when I experimented with those drums. That the blow or striking of air against glass of a certain minimum thickness is what excites light, and that is why I saw the twisted glass carafe shine, and not others of very thick glass. 28. And that same consideration, that metals do not shine, and that glasses must be of a certain thickness to shine, further confirmed my initial thought, namely, that the light of my phosphorus is indeed the light of electric fire. For we know that from metals, electric fire cannot be originally excited, since it is excited by glasses, which contain a very scanty quantity compared to metals, and they contain it in a state of such mobility that the large quantity they contain allows them to shine whenever they are agitated, and that they indeed move more easily from glasses of a certain thickness. 29. However, such a reason, with such great congruence, would not have fully satisfied me if I had not been able to strengthen it with some other conclusive experiment. If it is, I said to myself, that electric fire is related to glasses, which is agitated by the gust of air and shines, a similar blow, why would it not move the electric fire from other bodies that contain only a slight dose compared to glasses? Such certainly are sulfur and resins. Thus I constructed a small cylindrical vessel of sealing wax, 1½ inches wide, about 3 inches high. I aimed to bring it to a certain sufficient thickness. I experimented with it under the drum, similarly as I had experimented with the carafes, and with delight I saw it shine with that particularity that no gust of air had yet shattered it. Therefore that experiment has confirmed to me what I had already employed to investigate, namely, that the light of glass does not depend on its breaking, and it has completely and definitively shown me what I had previously conjectured regarding a new phosphorescence. That is to say, that it is truly light from electric fire, which an impetuous blast of air produces not only from glass, but also from other electrically charged bodies, and thus it becomes apparent. 31. But perhaps I have already detained you too long regarding that exceedingly subtle matter, the delicate and sublime sentiments, most illustrious lady, which are very familiar to you. Nothing in nature is so small that, from the understanding of individual facts alone, one could proceed to the broadest knowledge. It is better for the perfection of science to analyze a minimal fact through experimentation than to imagine dealing with the universe. Those sentiments, I say, with which you regulate your continuous applications and judge those of others, are indeed what have persuaded me to be able to entertain you at length, and not without delight, regarding a new glimmer of light and the experimental explanation of it, in which my good will, asking you to recognize it as an act of my profound respect, is united with